Welcome back, everyone. We are here for day 4 of the completely free uh, Certified Cloud Security Professional Bootcamp to prepare you for that CCSP exam. My name is Mike Gibbs. I'm the CEO of Go Cloud Careers, and I've been every kind of IT architect you can think of for the last 25 years and loved every minute of it. I am one of the first Cisco certified internet experts, and I did the CISSP and other cybersecurity things the first time about 20 some years ago, almost 25 years ago. So I'm joined here by Mark Milovanovic. He is our Chief Technology Officer. He is also a Cisco certified internet expert with an incredible deep knowledge on cybersecurity. So we're here to do this completely free bootcamp for you. So hopefully you're having a good time. Hopefully you're learning a lot. We finished yesterday with an intro to cloud security. We're going to dive a lot deeper into that today, which is going to be fun. I want to make sure that if you don't have a copy of the free ebook our organization wrote for you to go along with this course, please go download it. My team will drop that into the chat box right now. It's also in the description of this video, and that is the free ebook to prepare you for the free CCSP exam. So please go download it. Mark, you remember what page approximately we are on that exam guide, so the students that are following along can stay synchronized?
Yeah, so either if you don't have it, of course, go download it so that you can follow along. Once everybody has a copy of the study guide, turn your attention to page 128. You should see a heading that says Cloud Security. And we're going to get into some more details in regards to what that entails, talking about some of the shared responsibility models. We'll look at some more things about virtualization again. So it's going to be a fun-filled session that we're going to have today. And what I will ask of everybody to please let's start this session off with a bang by making sure that in the chat box, we put a hashtag CCSP. That lets us know also who all is here, that you're wide and awake and ready to take in a lot more information in regards to what is required of a cybersecurity architect when we actually focus it down towards the cloud itself.
Absolutely. I'm thrilled you're here. Let us know where you're at. So I see those hashtags CCSP. I love it. Good to see some of your names. So many of you I actually know. Some of you are new to us, and that's great. We are thrilled to actually have you here. So again, really excited to go back to this concepts and the studying on the CCSP. Every Thursday, we have a How to Become an Architect webinar. If you missed today's, don't worry. You can actually get one. Join us next week. My team will drop a link for that as well. So welcome to the actual program. We're going to get into day 4, and we're going to begin with a recap of where we ended yesterday with regards to cloud security. As always, we'll speak for about 20 minutes or so based upon, as Mark and I feel around 20 minutes in our heads. So that could be either 20 minutes, 30 minutes or something like that. And then we stop for 10 to 15 minutes to answer questions. So you'll recall that with the cloud, we're outsourcing our data center needs to the cloud provider to a degree. So I want to rehash what is that shared shared responsibility model. And the key here is you as the organization or the customer that put your systems and the cloud provider are responsible for your systems. So if an organization puts virtual machines in the cloud provider, they are responsible for the security of those virtual machines operating systems, whether they're locked down, the network security inside of their VPC or their VNet access list, for example, security groups, firewalls that may be placed, net routing and security, and anything you need to do to protect your stuff. So that's the key. You always have to be responsible for your stuff, whether that be your network security, whether that be your identity and access management. The cloud provider, by comparison, is responsible for securing their stuff. So what is the cloud provider's stuff? Well, for the most part, it is their routers and their switches and their underlying infrastructure. It is their servers. It is their storage. It is their physical load balancers, their physical firewalls, and everything that makes their data centers run. They are responsible for that. Now, if they're offering you a platform or a function as a service offering, like a Lambda function or an Azure function, in that case, they're responsible for everything other than the code that actually runs. and whatever your identity systems are that are associated with other things, because that's running on their servers and you have less control over it. So the more control you need, the closer you get to infrastructure as a service. The less control you need, the closer you get to that platform as a service, function as a service, or software as a service. But just be responsible for what you have to manage. So remember that the data owners, the data creators, the business is always going to be responsible for whatever happens in a breach. If I'm the CEO of a hospital and my hospital records were breached, my IT systems like our electronic health records and our physician order entry systems are all down, and we can't get access to patient records. If someone were to die while that occurred because the hospital couldn't do its job right, the CEO of that hospital would be responsible. Now, even if the CEO put those systems on a cloud provider, the CEO would still be responsible for what happened. Now, the CEO's company could then sue the cloud provider for some financial opportunities or back in the back end, but the ultimate liability of the breach is on the business that's been breached, even if much of your security is outsourced to the cloud provider. So in super high security environments, some people won't outsource their security for that reason, because they're responsible for things outside of their control. So realize if something big happens to a business, regardless of whether it's your fault or the cloud provider's fault, that can have an impact on the business. If downtime to a business is $1 million a minute and the business is down for 6 hours, well, that's $60 million per minute, and 36 million. It was 300. Was it $3,600 million per hour times 6 hours? That's quite a lot. So an organization with those needs would basically, can they sustain those losses? And just because maybe they get a refund on some of their cloud business, that doesn't mean it's enough to help that business. So understand that ultimately the business is responsible for its own definitive action, regardless of if they outsource it. So think about that. That's why organizations typically use more than one cloud as opposed to single cloud for that reason. They can't outsource it to somebody else and hope for the best. They have to spread the risk across multiple organizations, for example. Negative publicity if something happens to a business is when their system's down. So it's not just the financial liability, but the ultimate thing lies with the customer. So when companies negotiate with cloud providers, they're going to try to negotiate on various parts of liabilities wise. And typically speaking, they may create certain terms of diagrams to show who's responsible for what kind of breach, what kind of problem when it would occur in the contracts that you might actually have back and forth with the cloud provider. And just recall, there's going to often be, conflicting perspectives when anything were to happen. So the cloud customer has to focus on their stuff. So what does that mean? It means, say, data protection, their production environment, and everything that occurs to their systems. The cloud providers focus more on that data center and that underlying hardware infrastructure and the security of their control plane, their hypervisors, those types of things. Now, the customer always is going to want the max control, but they have to give away a lot of that control in the cloud environment. So think about that. Now, the cloud provider's objectives are to keep their systems locked down, hardened, and solid and running, which means, keeping those systems locked, having good operational procedures, those types of things. That's why you're not going to be able to go view what's in the cloud provider. So you're going to have to hope for the best that they're running the right way. And understand when you actually separate your business between, say, the provider and you, if something happens, you and the provider are at odds with each other because you now have different interests, legal liability wise. So just think about these things. These are the things that need to be planned of when people consider the cloud computing. So that's a refresher of the last parts of the intro that we did yesterday. So now let's get into cloud computing risks by deployment model. And you have to understand the risks of each model and understand the models themselves. So whether you're dealing with a private cloud, there are risks. Whether you're dealing with community clouds, there are risks. In a public cloud, there are risks. And hybrid clouds, there are risks. So let's talk about the hybrid cloud risks. So in a data center, you can obviously create the greatest security. You can create a much greater security environment in the data center if you choose to than you'll actually get in the public cloud provider space. Now, that's not saying the public cloud provider is not secure. And it's also not saying that the public cloud provider isn't more secure than a poorly run data center. And many organizations have poorly run data centers. And that's also true. But if you're building it yourself and you care and need the best security, you can create it in the private cloud. So in the private cloud, you've got ultimate control over your network. You can separate your segment your systems via VLANs, which are basically they'll all be on different subnets, and then you can limit routing information between subnets. For example, you can also run ACLs between subnets. You can actually create VLANs at layer 2 in your data center. They're called private VLANs, where you've got two devices in the same VLAN, and they can't even talk to each other. So you can limit devices at the layer 2 level long before we even need access list to be able to talk to each other. In the private cloud, we have network security where we could prioritize mission critical traffic over, say, worm traffic. There's so much we can do in terms of more additional security in the data center. So in a perfect world, the data center is the lowest risk if the organization has the right people. So full control over everything, the most capable security if they've got the right people. And what's going on here is you're going to have to build the same data center the organizations as they always would, which means they have one or two power companies coming in. They've got generators, backup generators, UPS systems and batteries. It means routers. It means switches. It means physical load balancers. It means physical firewalls. It means servers, and it means the same storage area networks. And all this stuff is put in the data center. The underlying network infrastructure is built, and the server's got a little software on it called cloud software. So VMware vSphere was basically doing this. OpenStack is doing this. It's a private cloud. Nutanix has incredible software. Again, it's a private cloud, and it turns that data center into a cloud. So why would organizations do that in this environment? Just imagine an environment where you need to create a server, and it can be provisioned on any of the servers the business has at any one time. You can do that with a private cloud. Or you build a data center with excess server capacity, and one application has more needs than the other. So all it does is it auto scales that application and it pulls it from other resources and capacity. And you can have your data center do this kind of stuff all day long. In private clouds like Nutanix and OpenStack, all these cool, serverless things you can do in your data center, functions as a service, things like Lambda functions or Azure functions. And all that agility and scale in and scale out businesses get in this private cloud. So the question on the security here is, do they have the right people in place? Do they have people that really understand physical security? Because the physical security is wrong. Do they have the people that really understand network security? Are these data centers being put in a good place with regards to power access, with regards to security? Or are they in a place that's easily attacked? So there's lots of things that need to go into designing the private cloud. But designed properly, this is the most secure because you can put as much as you need there. The situation here is the person has to buy all their own gear. So they have to purchase it. Now, that doesn't mean they have to pay cash outright. The organization can finance that gear. They can lease that gear. If they wanted if they wanted a capital expense, they could purchase it, even including finance it. If they needed a capital expense more for the write-off as opposed to the depreciation, they could take that and they could actually lease that gear. So lots of things to do. So just understand that in the private cloud. So who should have private clouds? And anything that needs to be really secure should strongly consider this architectural option. So highly regulated environment, organization that's possessing a lot of top secret organization maybe should have their own, because they can put in very detailed security controls and very detailed governance. But this could be, in some cases, more expensive than the public cloud. It might not be, but it could be. And it's all going to be based upon what that organization actually needs. But the most flexibility and opportunity here for the highest security. Now, in a private cloud, there are also some risks. So natural disasters. If the private cloud is just held in one geographic region, and there's not a second data center somewhere else, the private cloud is a problem. Now, if the organization has more than one data center with their private cloud, that risk is substantially mitigated. Personnel threats. So, if something happened to the people in that data center, if they were hijacked, for example, that is a threat to that small data center. And there's typically going to be less security controls in place for a private organization than there might be a bigger organization. But if you're building a private cloud and you have critical security needs, you're going to have really good physical security too. Attacks. In the private cloud, just like the public cloud, it's still, you can get the same kind of attacks. Somebody could come at you with a DDoS attack, those types of things. So, you're not free of attacks. You've got the same attacks on the cloud and off the cloud. It's just you've got more things you can do at the network level, network security wise, in the data center. And in the private cloud, you can still do all the cool IAM things you can on the public cloud or in a zero trust environment and still have network security at the same time, which means you've got a double layer of security. Let's talk about a community cloud now, because this is an interesting environment. It's an interesting environment when you get a bunch of businesses in a small environment. They pull together their money. They build themselves a private data center. They put basically, or a private data center for just themselves. They put cloud software onto this data center, and then they rent it out and share it to you amongst businesses in the same industry. Now, think about this. Let's say, for an example, you've got systems that need to be designed for healthcare. Healthcare's got a certain level of availability needs. It's got a certain level of performance and security needs. And at the physical level, you could build that where it was optimized for those healthcare kind of workloads. And then at that software level, cloud level, you could tune it or optimize it for that particular set of the populations. Because architecturally, when you design something, you're always going to face these choices. Option 1 will make you better for something and worse for something else. Option 2 will make you better at one thing and worse for something else. So architecture is really about an evaluation of all options we have and determining what's best for our business after we evaluate all trade-offs and see what's going to meet our specific needs best. So we could tune a community cloud a little bit in the way we do our systems for that unique industry. Now, here, what happens is because you've got a bunch of people pooling their money, they get an economy of scale, which is a good thing. At the same time, they don't reach hyperscale like a cloud provider. And hyperscale is when you have so many people that you need layers and layers and layers of management. You can look at any government across the world that's got a lot of people working for it. They're big, they're great, they do what they're supposed to. I'm not saying anything negative in any way, shape, or form. What I'm saying is they can't be as efficient when there's 1 million employees or 10 million employees working for a business, or even more than that, than when there's 5 people working for a business. It takes a lot more to manage a hyperscale environment. So that's what's good here. So you're not that big that you need hyperscale, but you still get the efficiency. And because basically speaking, you're designing your own cloud and you're running your cloud, in many cases, this is going to be cheaper. And it's not like we have to worry about various different industries that the cloud's optimized for kind of everything as opposed to tuned precisely for what we need it for. But still, it's shared. So there's still risks of a shared environment and how those systems are actually maintained. So it's also going to be on the sophistication of who's running that community cloud. Benefits are the shared costs. Access is shared, but also some of the risk is shared as well, because now it's no longer just your data center as a single business like a private cloud. It's a couple of businesses, and potentially if any of these businesses are attacked the wrong way, they can serve as an attack vector to the other ones. Shouldn't be the case in most cases, but it's potential. So think about that. But this makes it easier from a budget perspective. But now you get into a world with lack of standards. Of course, nobody has any serious standards. So, but it's a lack of standards, and it's going to be based upon how you guys or how the people in the business, guys, gals, everywhere in between, actually go and build it. So keep that in the back of your mind. So now let's talk about a hybrid cloud. In many cases, this is the best option for businesses, but not always. And you still obviously need to know the businesses. But a hybrid cloud is the private cloud, which gives you the peak in performance because it's closer to you with the least latency, the maximum level of security that you could potentially implement. and the lowest cost for high performance systems that need to run 24 hours a day, 7 days a week, and still leverage the public cloud for what it's good for. The agility of the cloud, the speed of time to market, certain enhancements that might be good for an organization's business. So they get to maximize the benefits of both. Now, here it gets a little more complicated because now they have two sets of security to maintain. They have to maintain their organization's traditional security in their data center, which is fine. And now they have to ensure the security of the systems on the cloud. And they also want to secure the data center from the cloud and the cloud from the data center in case each one of these situations would get hacked. So it makes it more complex. But if you've got the right people, it's still no big deal. It's just now you need a better grade of people working in your data center. And it's not always easy to find people that have got the sophisticated set of skills to do it when there's a lot of things to plan. But for organizations highly dependent upon technology, they're going to need those people anyway. In a hybrid cloud, typically speaking, an organization can get better compliance because they can come up with any standards they need to adhere to. They've got a lot of knobs to turn, if you will, and they've got better control over sensitive data. The challenge is in the hybrid cloud is now you've got two separate environments, and you need to can make sure you've got a consistent security policy in both environments. All right, so now the public cloud, and this could be just going to an AWS or an Azure or a Google, an Alibaba's cloud, a Dell's cloud, the Cloudflare cloud, which is a great cloud. There's lots of clouds. So in this particular case, we're now outsourcing to another vendor. The benefits here are we've got a lot of agility. We also have a lot of scalability. In most parts of the world, the cloud providers have additional capacity. There are parts of the world and environments where the cloud providers are running out of capacity in certain data centers, but they had capacity when that occurs. But for the most part, the cloud providers always have excess capacity most of the time. So you've got that. Plus, the cloud's pretty agile. You can just, it's there and ready for you to use it. So you don't actually have to bring things to you. And in some cases, if you use these types of platforms as a service, organizations can focus more on code than the underlying infrastructure, which in some cases can be faster. In some cases, that can be better for them. In other cases, they need the control and the performance of doing them themselves. But that's all decisions that need to be made by the architecture team. But the risk in the public cloud, if it's all there, is relatively low for most organizations. If they use the main tools from the single cloud provider everywhere they can be applied, and then they use more industrial tools, say at the edge of the network to protect, say, web servers, you can get a relatively secure system fairly easily on the cloud. Now, is that top-notch cloud security? No, not by any stretch of the imagination, but most things in there are inherently designed to be tied together to a lot of the cloud providers' native tools. So it's relatively easy to get to a decent level of security on the cloud with most of the cloud providers' native tools and maybe some different firewalls, etc. So that's pretty easy. And it's going to be harder in many cases to get that level of easiness in the data center. So the data center, we can get much more, but it's actual work. And many of these systems on the cloud providers are much easier to get to the same degree of security in the cloud. So that's one of the benefits of the public cloud. Your team can be slightly less sophisticated, which means less expensive personnel for the people to find. And it's rare and hard to find a really good technology professional. And when you see one, you interview them, you hire them on the spot because it's so hard to actually find them. And those you don't need quite as many of those folks on the cloud as you actually would in, say, the private data center, where you have to manage everything from, the power, the cooling, the infrastructure, the networks, routers, switches, cards on these networks. At some point, it has to get pretty granular to run your own data center. And the people you need have to be pretty sophisticated. Here's the risk in the public cloud. Cloud provider gets hacked, you get hacked. And this is especially bad if you're using shared cloud provider services. So for example, I usually talk about not using proprietary databases like DynamoDB or Azure Cosmos or Google Cloud Bigtable, not because they're not great databases. These are really good databases. But 98% of the world that I work with is an enterprise, and they're multi-cloud, so I can't use these kind of databases in the multi-cloud environment. So when we think about this, that's one thing why I don't use them. But imagine, and I try to use with more open standards whenever possible, unless the proprietary database gives my business or the business I'm consulting to some enhancement. By comparison, if an organization is using a platform as a service like Azure Cosmos DB, which is that no SQL database, which is a fully managed database, when Cosmos DB was hacked into, many customers' information was also hacked into because they hacked into the cloud provider's managed service and then got access to the underlying customers. So that's an additional risk you have in the cloud. You have all the same risks in the cloud for the most part as you do the data center, but now your risk in the cloud is that the cloud provider gets hacked, because if they get hacked, you can get hacked too. So that's the big new risk in the cloud. Kind of think about that when you're dealing with your clients and they're asking these questions. But remember, the public cloud is just a data center. You're renting space in their data center. It's just a virtualized data center. And I always viewed it to me as a house versus a hotel. You know, you can build your own house and live in your own house. I personally love that. Or what you could do is you could build a hotel and you could create a whole bunch of apartments in that hotel, and you can rent those out individually and charge a lot per day for them. That's cloud computing. Instead of you buying your own house, which is your data center, you rent a room in their hotel and you pay for the services. And you've got this convenience of them doing the hard work for you, keeping the pool clean at the hotel, if you will, keeping the grass cut, making the palm trees look beautiful, those kind of things it's done for you. So that's some other real risks to businesses of going with the public cloud is loss of control. When an organization's doing it themselves, they've got people focused on every part of the equation. Often when people move to the cloud, especially with the critical cloud skill shortage, very few people even realize cloud computing is renting space in somebody else's data center. They don't actually get it. They've got it some fancy thing without understanding what it actually is. So when organizations go there, they often lose their expertise with managing the systems themselves. And they lose focus of all the pieces and parts of what they used to need, especially if they lose some of their expertise and personnel. Now they're on the cloud and they lost track of the big picture. They lose oversight. And now they can't audit. So there's that loss in the public cloud. The next thing is vendor lock-in. Depending upon how organizations go to cloud providers, this can be a big risk to their business. So as an architect, generally speaking, what you're trying to do is you're trying to make your client's business optimized, but also more flexible and more agile. So if something changed macroeconomically, your client's business can easily adapt to it. If the client needs to do something business-wise and they need to add something, the core functions of the infrastructure are designed to expand with it. They're agile. So a lot of that is what you're trying to build. And part of that means being able to have an infrastructure that can take any application or any device from any vendor and use it at any time. If organizations go cloud and go too careful on then using the native features and functionalities on the cloud, and they start using native cloud provider tools, now all of a sudden, if they need to go back to the data center, it's going to be very hard to, if their investment didn't work out on the cloud. And in most organizations' investments haven't worked out on the cloud. Now, to be fair, most organizations' investment haven't worked out in the data center because in many cases, the architects tried to engineer the solution, meaning start with the tech, as opposed to taking the business functions and solving business problems and then marrying that to the tech. But that vendor lock-in is a real nightmare. So how do organizations prevent vendor lock-in when they go to the cloud? Fairly simple. And what they do is they don't use any cloud providers' native tools, so no proprietary products. And then they it's never a challenge because they can put whatever applications they want anywhere, anyway. So think about that. And the next time someone's saying, should I use this cloud native database? You have to be able to think about all those implications and how that would affect 2 years from now, 5 years from now, 10 years from now, etc. So another concern with the public cloud is proprietary formats. Data may be stored in a different way than it might be. And anytime we get into proprietary, we've got to manipulate it on the way in and then manipulate it on the way out. And that gets challenges. Other challenges are contractual constraints. So, you'll find businesses that want to leave and can't leave and continue to stay there for longer periods of time. Regulatory constraint make it even harder. Which providers you're actually using? Do they meet up to certain standards? Although for the most part, the big cloud providers meet most regulatory standards. So avoiding vendor lock-in by not using proprietary things. When you deal with any external provider or any vendor, you should always have your exit strategy in place while you're already negotiating the way into the contract in the first place. Make sure you don't use proprietary formats, proprietary protocols, proprietary cloud provider, anything. And make it easy to get the data back and forth to each other. But the real key is just swap out an AWS WAF, swap it out with a Palo Alto firewall, or a Checkpoint firewall, or a Cisco firewall, or a Fortinet firewall, something that's bigger and more industrial anyway. Swap out an Amazon Aurora with an Oracle database, for example, on all your cloud providers, no big deal. And it's not because they're not good. You just want to use open standards whenever possible to optimize flexibility, unless there's a business reason because that proprietary something does something for that business, which enhances it. Now, when you go to cloud providers, typically speaking, make sure you've got enough network bandwidth to get data in and data out if you needed to. Make sure that whatever bandwidth is going to that cloud provider is sufficient for all of your users. And make sure that, realistically speaking, that whatever providers you're working with have some kind of data exportability features and functions for you. And don't just deal with one provider. At least during that RFI, RFP, RFQ process, speak to multiple cloud providers and look into how they adhere to various regulatory requirements like HIPAA or FERPA or PCI DSS, and kind of look at how these organizations are actually working with it. So there's that. Let's see, how long has it been? You know what? I think now's probably a good time for us to pause and take questions, and we'll get into some other things. We'll get into a lot more, actually. Okay, from my team, are there any questions we need to address right now that you know of have come in?
Yes, there's a couple of questions that we can take and address. I believe the first one is from Chris, and he's wondering, do you know of good places to get practice exam questions? Chris, I do know of a very good place that you can get practice questions. But before I tell you so, and I'm not trying to tease you on purpose with this, I do want to make a recommendation to just your general study habits for yourself and everybody here. All the questions that each and every one of you comes up with, or that you see others come up with, I would use them in creating my own practice questions out of them. Because generally speaking, if one has the question, multiple other people will have them as well. In addition, anything that comes to your mind, I would say is fair game, as in regards to your own personal questions that you can add to your repertoire. And as you go through the study guide, and let's say if you have the official study guide also provided by IC Square 2 or by IC Square, you can also use their information as well as some of the practice questions they have in there. If you wanted something, though, that is kind of pre-made for you, and again, the other option is a little bit better because you have to put some skin in the game, as we say. You have to put some effort into creating your own questions. I would suggest that you get the official IC Square exam preparation app. You can get it both for iOS and for Android as well. I'm going to drop that link into the chat box for everybody. You can pick this app up. It's going to be good for the CSSP, the CCSP as well. And you can pay for it either when it comes to a monthly or an annual fee. But let me do this. Practice questions. And you can take a look at that link in particular. That's what I would recommend. All right, let's take a look at the next question. And this is from Kennedy. They're wondering, does it mean that the data owner has more responsibility than the cloud security provider? In the case of a breach, who is liable? You want to take a stab at that first before I give my opinion?
Yeah. So legally, the business is responsible regardless of where that data is hosted. So if the business has their own data center and they get hacked, the business is responsible. If the business is on AWS and they get hacked, Azure or Google, they are still responsible. If Azure gets hacked or AWS gets hacked and Google gets hacked and they get hacked while your business is on AWS, Azure, or Google, you are still responsible even if it's their fault, because you are ultimately responsible for your business. So if your business, for example, is an airline and the cloud provider, and you put your systems in the cloud provider, and all of a sudden the cloud provider is no longer with us because they're having outage for some reason, and you've got planes that are flying in the sky that you don't know where they can land, as you can imagine, that's going to be a pretty big issue. Sure, your service level agreement with the cloud provider will say, oh, we didn't give you what you need, here's some money back. But if one of those planes that were flying around lost fuel and crashed into the ground, that loss of life, would never become close to that SLA. So the business is always responsible for their own security, regardless of who does it.
Correct. And just like Mike mentioned, that's why we're looking at the shared responsibility models. And I'm going to, Chris, if you can bring up the question from SR as well, because he talks about service level agreements as well. So I can kind of add that into it. So the important part is ultimately you're the data owner, are responsible for your data. And what I mean specifically with that is if you're storing anything, let's say something as, I suppose I shouldn't say innocent, but let's say you're storing logs in one of the cloud service provider storage things, whatever you might want to call it. I don't want to put out proprietary names. And you don't, let's say, encrypt it while it's just sitting there. And there's a breach. Depending on the origin of that breach, sure, it would either be your responsibility or let's say the cloud service provider. But let's say there is a breach with a cloud service provider and you just don't follow good practice in encrypting your data. Yes, it's going to be their fault to a certain degree, but ultimately you're in control. It's your data. You should be skilled enough. You should be taught enough. You should be competent enough to understand that there's a shared responsibility model here and that you can't just blindly trust anyone else with what is considered your data. So from that perspective, you should always keep in mind that it's your responsibility to make sure that it's secure. But I would also say in regards to service level agreements too, depending on how much of your private infrastructure you're eventually going to be outsourcing, because that's what you're really doing when you're renting resources from the cloud. You're outsourcing a private piece into a public piece. So if it's going to be outsourcing your infrastructure, then you clearly would want to take a look at your service level agreement, because that's actually going to give you the details in regards to who is responsible for what. And if you happen to have something like let's say a data processing agreement, that also would outline how data generally is going to be handled. And this is also very important, especially if you have some type of compliance requirements like HIPAA, or if you have in the European Union, you have GDPR. That's going to be very important also to keep in mind. But ultimately, you're responsible for your data and make sure that you can secure it. And if you're not 100% sure for some reason, read your service level agreement.
And let's make it clear, every environment is mix and match. If you deal with an enterprise, you're going to be dealing with 100+ vendors in every situation. And that's, what we architects are dealing with. We're looking at all these things coming in from all these people and what are the implications. And that's why people think architects are touching tech. We can't be touching tech. Just that kind of stuff, just thinking about this could take a month's time with all the applications we actually deal with. Great question, actually.
Yep. All right. Next question that we have, let's take a look what it is. This is from Andreas. They're wondering, can auto-scaling be leveraged for cloud resources, specifically transit gateway and express routes? What you're describing here, Andreas, these are already network infrastructure pieces that cloud service providers are going to provide you with. They're by default already scaled and redundant and high available.
Well,
if that's what you
let
want.
let me highlight that a little differently. So the express route is a private line. So there's no way that a private line will be auto scaling. They have the capacity from their point of presence data centers back to the cloud provider, but you can't auto scale a private line. You want to get a private line, you call the telco, they build you the private line. It takes 4 weeks, 6 weeks each time. So there's no way to do that. Now, can we scale virtual routers inside? That's a little different, or virtual firewalls. Yes, we can. But these kind of wide area network providers, they're no different than the wide area networks in any other environment. We can't just auto scale them. But we can scale, as Mark's saying, all those resources internal to the cloud. And many of those internal networking standards will, but this in particular is exactly a private line. And unfortunately, you just can't scale that on fly. I wish we could.
Yeah. What you want to focus on in this case, Andreas, and I'm going to tie this a little bit also in your other questions, because you're trying to get very specific with the cloud service providers solutions, is you want to focus in this case. Mike mentioned stuff that you can't just auto scale, which is going to be the physical infrastructure. When it comes to the logical aspects of these network services, yes, that's going to be scaled by the actual cloud service provider. Your focus should be on the monitoring, on any type of custom configuration that you would have. This is your engineering side of it. And then from, let's say, from a security perspective, is what can you do to effectively secure traffic that is going to be traversing these services? So that's where you would have to find out, am I looking at IP security? If I have some type of direct connection, am I going to look also to secure device-to-device security? And then, of course, there's other ways when it comes to depending on what routing protocols you use and what type of logical constructs you use, depending on who your cloud service provider is. But your focus should not necessarily be on the scaling aspect of it, but rather on the parts that you actually have control about. And that's also going to tie into the question that you brought up in regards to what we say, how do we measure the capacity in context to direct connections and express routes? Same thing. First of all, you need monitoring to create a baseline before you can even try to figure out what are you going to be looking at exactly. And that's also going to vary based on the flows that you want to be taking a look at, and also what I mentioned, the business driver. Is this based on capacity planning, or is this going to be based on planning when it comes to security? So those are going to be two distinct things that you will have to look at. One of them is not going to be in your purview, while the security aspect will be in your purview.
Yeah.
Hey, Mike. Okay, so we just touched on that. So Love in the Bootcamp, what metrics do we measure when looking at capacity in the context direct connection and express routes from core network to CSP? Did you want to add anything to that, Mike?
Yeah, so Andreas, they're the identical metrics we would always look at with a wide area network connection. How much bandwidth do we need? What are the latency we need? Do we need performance guarantees in our bandwidth? But, I'd suggest if architecture is a desire, I'd suggest you focus on, you start thinking higher up instead of each individual thing. I would think about what's necessary for the wide area connection, what's necessary in the compute infrastructure, compute side, storage infrastructure, security infrastructure, secure IAM security, network security, data security. It all depends where you really want to be. But kind of hope that helps.
Good. Okay, let's take a look at the next question. Okay, so what states have more legal protection for business owners if you took proper MES, if that's answerable for the US? Scooby, let me answer it this way. That's why we have a legal team. So that legal team can focus on the details when it comes to any type of compliance and governance, because even though you're going to have somewhat of a high level overview, when we're starting dealing with federal, then we're starting dealing with states, there's just too much to keep track of. You want somebody who is really involved in that process and understanding those minutiae of these type of state laws. So I don't have a succinct answer for you on that one. Besides, you should get together with your legal team and get their advice.
And they will have a different lawyer per state where they do business, because each state has different legal rules. That's how dive deep it has to get.
From Anthony King, is accountability and responsibility being used interchangeably in regards to the CCSP? And the CISSP, there is a clear distinction in the exam.
They are different. They are different. So here's the thing. If I have Mark rebuild our new network, he puts in a new network, and along the way the network breaks, Mark's accountable, right? But if my systems aren't accessible, I'm responsible regardless if Mark dated. So the responsible is who's the party that's basically the owner, who's the one that's potentially going to get sued, who's the one that's responsible for, if the systems go down in a hospital and something happens, who is that person that's responsible? Accountable, maybe 10 other people along the way. So no, there's actually a difference technically if you actually use them. In English wise, no, but technically legal wise, there is.
Yeah. And also one is going to be task orientated. The other one is going to be outcome orientated. So responsibility is task. Accountability is going to be outcome orientated. So that's also going to be a difference you'll have to keep in mind for the actual examination. All right, let's take one more question and then we'll get back to the content. All right, from Pygong, they're wondering, for cloud infrastructure design, should data compliance adhere to the regulations of the business operational country or the data center's location?
Both.
It would. Exactly.
And sometimes more. So, sorry, I didn't realize Mark was going to do it. So that's the thing.
The same answer, both.
Yeah, it's going to always be both. Yeah, and that's why multinational companies have legal teams, and they literally speaking have country lawyers in every single country, and then they got other lawyers that do international law, and then they have different lawyers in the states they do business, because you're responsible for it all.
Yeah, and so my answer is the same. It's both. That's why you want to make sure you get with your legal team also to figure out exactly what it is. Transnational, of course, there's going to be a lot more things that you're going to have to keep in mind. But in either case, keep up the great questions, everybody. And just as a little reminder, if you have not done so already and you enjoyed the content today and what's been presented to you over the last few days, be sure to hit the like button. And once we get off the actual bootcamp, feel free to share the recorded session as well as any future sessions that we have planned. All right, let's get back to you, Mike.
And let me get back to Claudia's last question. She asked, is the flow of the training aligned to the layout of the book in each chapter? Yes. So what we did is I created the training with Mark, and then my team wrote the book to follow the training. So that way you had something that you could go back and work with throughout the entire training program based upon the flow of this course. Okay, so now let's talk about a concern moving towards cloud, which is something called vendor lockout. Vendor lockout is something that every business should be concerned of. Vendor lockout occurs when maybe the cloud provider goes out of business, or the cloud provider is acquired, or for some reason the cloud it just shuts down. This can really impact a customer if they're only in one cloud. Vendor lockout is also when a cloud provider says you are no longer welcome in our data center, and therefore you're kicked out. An example is, and I'm not going to say whether this is right or wrong, there was a company called Parler. Parler designed their systems and placed them in AWS. Parler and AWS didn't get along regarding the nature of the business, and AWS said to Parler, goodbye. And they no longer had their infrastructure that they could deal with because they were kicked off of the cloud that they were at. I don't know the legal specifics. I am not a lawyer. I don't have any legal opinion on it. But any kind of vendor lockout like that is a risk to the business, and all businesses have to plan for these types of environments. So organizations need to think about all ways that vendor lockout could happen and be prepared to deal with it and take steps to mitigate this if it occurs, and or using different types of cloud, and or having backup systems, or at least something. So that becomes a risk that an organization must deal with. So things which go into vendor lockout considerations is on the provider side, how financially stable are they? You can look at it right now. AWS, Google, Azure, they look pretty financially stable to me, but I don't analyze their financials on a daily basis. But they've all been in business for a reasonable period of time. Microsoft's been in business longer than all of them and has an incredible track record. So organizations are going to look for the stability of the cloud provider. And there's always going to be new cloud providers that exist and emerge. There's lots of them, many more than you would actually think of, other than just the ones you hear every single day. And when you deal with a provider, you really want to see what is their core competencies. So can that provider meet all your needs? For example, none of the providers have equivalent networking that we actually had in the data center. They're a decade or more behind. But in most businesses don't need all those networking features and functionality. But if they did, they go private. When you look at the cloud provider, when you evaluate a provider, are cloud services everything they do? Or is it something that's in addition to their portfolio? Because if a whole business is cloud, you're not going to stop it overnight unless it's going out of business. And if it's publicly traded, you could see it. By comparison, if it's a business that has many other businesses in that division, if they look and say, I don't like the way this division's going, they can just sell off that division or cut the division and close the division. Give customers a period of timeout or notification. So there's that people are going to be concerned on. When you deal with a cloud provider, how's their staffing? Does their staff like them? Does their staff love them? Because if the staff doesn't like that provider, you're going to have problems. Because when people are unhappy, they don't do good work. Does that company have all the resources they need? Things that you have to think when you plan on going to the cloud provider. Vendor lockout considerations. How about jurisdictional suitability? Is that business going to get sued by a regulatory industry and change something? Are we not seeing big governments going after certain tech companies as monopolies right now? Not saying right, wrong, or anywhere indifferent, but these are considerations that businesses have to face based upon these vendor lockout type considerations. Where does that business have their data centers? Are they in stable parts of the world? Do they have the appropriate protections if they're not? Something you have to think about. So there's a lot of things that go on when you're making these kind of contracts with these cloud providers that you need to think about. And it's not like, when Mark and I were doing network architecture, and when you're dealing with network architecture, because that's a specialty architecture, it's pretty technical versus normal architecture. We're thinking about where the copper wires are that are under the ground coming into the building and making sure that if we go to two different providers, they're not in the same conduit under the ground. So even though they're different companies, they can both be taken down with a backhoe pulling up a cable. So there's a lot of planning that goes into architecture. It's all planning, but it's those kinds of things to think about. Now, when we think about our provider, let's think about supply chain dependencies. Does the provider we deal with depend on other companies? And if so, what are their relationships like with those other companies? Are those other companies being bought out by someone which makes them no longer to have that relationship? We have to always think about these challenges. We have to identify any kind of vendors, suppliers that we're going to work with and how they're going to work together. And we're going to realize that we're never going to get the complete set of information in most cases, because we're not going to get all the dependencies that every business has on someone else. They can't put this information out for their own security. So we're never going to get as much information as we're going to need to be completely comfortable. Some people can let that go. Some organizations cannot. Whenever you're designing anything with the cloud, we need to think about the legal environments. You're going to have to stay informed about potential statutes that can impact your use of the cloud provider, which means make sure your compliance team has the lawyers and they're up to date and you're asking the right questions, because they need to focus on it more than you. Understand that things like Brexit happen, and that would affect companies and the way they did business in both the UK as well as Europe, because these things just happen. So there's that. Now, we also remember that the cloud is multi-tenant. It's my stuff, my competitor's stuff, their competitor's stuff, and thousands of other people all at the same time. So no one really owns their own systems. That means They're risks that we need to deal with. So lots of risks exist specific to the cloud. So some of them are conflicts of interest. And here would be a conflict of interest. If someone at the cloud provider tried to do something on your virtual machines and changed your tech, the cloud provider is not allowed to touch your stuff unless you've got a contract asking them to do it. You manage your stuff, they manage their stuff. So there's going to be a lot of points where there's conflicts of interest, and they're going to be spelled out very, very carefully. Escalation of privileges is something we have to worry about in the public cloud. We may have authorized users that try to get additional privileges to be able to do more. This exists in the data center too. Someone gets unprivileged access to a router and then tries to get to privileged access on the router so they can make changes. But, at least in the data center, we've got a lot more controls we can do other than identity and access management. And in the cloud, we lose so many of these things, which makes us much more geared towards IAM, which is why, zero trust architectures become more and more critical on the cloud because of the lack of traditional security and boundaries, things like that. So we have to think about these things and their implications. If we've got on the cloud, someone gets access to administrative access illegally or illicitly in some way, shape, or form, they can do everything. And if somehow somebody were to get root access, they could just wipe an organization's entire environment away. You don't have that risk in your data center. You're not going to wipe your data center down in a couple of seconds, but it's pretty easy with root access to basically delete everything, and the company's got absolutely nothing. So that is a huge risk in the cloud that no longer exists, that didn't exist in the data center, because data centers have lots of physical devices, and there's lots of key. There's just so much that goes into it. It's not going to be done by one person in a few minutes. Another risk specific to the cloud is what's called information bleed. So your storage and 1,000 other people's storage or more are all going to be in a similar server or group of servers. So there's the risk that one customer's data were to somehow bleed into somebody else's. Is it rare? Yes, absolutely. Or you also have the potential possibility that somebody deletes information in their systems, but it doesn't delete theirs and it deletes yours. Is it a big risk? Not really, but it's enough about it for them to want to talk about it and have you prepare for it for the exam. So just think about it. Legal activity-wise, well, in the data center, data and devices can technically be subpoenaed or seized as evidence. In the cloud, if that were to occur, where certain systems were seized as evidence and your systems were on there, that might not be a good situation. But hopefully, your information would be backed up. But if something were to force something to be shut down, that could still impact your business, depending upon how you would work with that cloud provider to move your systems. And hopefully they would move them for you. But understand, there's all these things, and you never know how somebody's processes go. But the reality is, if your information is on a server and it is seized, your information is also seized at the same time as somebody else's information. The real risk to the business is that the cloud providers are the highest value targets in the world. And you have to understand that people are trying all day, every day to hack the cloud providers, because if you hack the cloud providers, you get access to all their data systems. Hack one business, get access to that one business. Hack a cloud provider, get access to millions of businesses. Imagine what you could do with that data if your desire was to do harm. So, high value target. Now, that also means the cloud providers have a lot of high value protections from it as well. So understand that, but it is a high value target, and nothing's going to be bigger of a target than the providers themselves for those reasons. So let's look at the cloud computing risks by service model. And when organizations are going to migrate to the cloud, each option, each choice they choose, will have a different set of risks and a different set of controls. So the majority of what we typically think of in cloud computing is either infrastructure as a service, which is basically you run a virtual data center, platform as a service, where many of the data center things are actually hidden from you. So you basically upload your code and your applications and it runs on their data center and you don't really know much about where it's running. And then they bill you for use. And software as a service, which is typically like Microsoft Office 365, where it's hosted somewhere else and you can log in remotely, that kind of thing. Your data is stored somewhere else. And each one of these models has their own risks. In infrastructure as the service, you have the greatest control over your resources, which can reduce the level of trust you need to have for your provider to a degree, and it can enable you to provide the most sophisticated degree of security. But it requires the most knowledge to know how to secure it. And that means if an organization is short on cloud security knowledge, and most organizations are short on cloud architecture knowledge, cloud networking knowledge, cloud security knowledge, cloud AI knowledge, most businesses are critically short on these skills, even cloud knowledge in general, that there's a good chance that it's not done right. And that opens that business up. So there's that. Also, we still have the insider threat. So basically, you can have an insider that's malicious and wants to harm the business, or you can have an insider that's just a little bit negligent, and they can open the door in the cloud. You've got a direct connection or VPN back to the data center. You didn't firewall that stuff correctly, and the people can come straight into the cloud and come attack you in your data center in a hybrid cloud or attack your system. So just think about these things. So your infrastructure as a service is going to be susceptible to normal attacks like malware, any kind of hacking you can think of, denial of service attacks or distributed denial of service attacks, on-path attacks like man in the middle, generally speaking, any kind of normal cybersecurity attack you would think. And many organizations lack the skill and the depth to actually do these things. So there's often insufficient training on the people in the data center, let alone on the cloud. It's near impossible to find people that have knowledge. Too many people in the cloud have been taught by people that never knew what the cloud was, that have made Udemy courses, and it put people in a bad position where they just don't know where to begin. So it's near impossible to hire people with really good cloud skills. It's just horribly hard to hire them. Now, with platform as a service, we have all the same risks we talked about before, although less on the administrative side, but now we've got interoperability as risks. So what if the cloud provider were to update some type of operating system or do something with one of their platforms as a service, and all of a sudden our code no longer runs? You never know what happens when organizations push code releases. CrowdStrike pushed something to various organizations. You saw the damage that it actually could occur. So we have to worry about that. We always have to worry about what kind of backdoors exist in our client environment. And the other thing that we have to think of is sometimes DevOps culture, which is really good at speeding up software, can actually increase risks because it's speeding things up more and more and more. And sometimes the velocity is so fast, organizations don't have the time to truly test their systems. And in many cases, by accident, people leave backdoors in their software. So that needs to be checked because this is heavily duty. You're relying on someone else. You have to hope they do it well. And in most cases, these cloud providers do these things very well. With platform as a service, and you have lots of virtualization risks because now we're using virtualized operating systems in addition to virtual machines. So there's a lot more going on the cloud provider. Basically, our systems and applications are going to be running on servers that are also running the applications, and we're hoping there's a separation in that server, which may be less sophisticated than a complete hypervisor virtual machine. So it's resource sharing. So again, with these platforms as a service, you worry about information bleed from one customer to another. Not that it usually happens. When it comes to software as a service, which is basically outsourced everything and it's hosted and managed for us, and pretty much the only thing we can deal with is our IAM, we've got all the risks we ever had before, but now our data is typically stored by a provider, potentially in a proprietary format, which gives us lots of vendor lock-in. And now we're in an incredibly virtualized, resource shared, multi-tenancy sort of environment. And we're at this point, we don't have a lot of security we can work with. We've got browser access and some APIs and very little bits of things that we can actually do. So, convenience factor, but the least security of the bunch. So we have to think about it. So one virtualization risk is called a hypervisor attack. You'll recall from day one, we talked about virtual machines and we showed what they were architecturally. And we talked about what is a type 1 hypervisor versus a type 2 hypervisor. We talked about that. And we have to be concerned that someone can break the hypervisor. So what do I mean by that? Maybe we can draw it out. And if what we're worried about here is if we have this kind of an environment, and it's not a common attack, but if this is our actual physical server, and on top of the physical server, we've got a hypervisor. And now every virtual machine we get in the cloud is running on a server with a hypervisor, whether it be an EC2 instance running AWS's hypervisor, whether it be an Azure virtual machine running Microsoft's hypervisor, or whether it be a compute engine instance on Google, it's running their hypervisor. It's still running a hypervisor. So there's that. And we'll put 2 virtual machines on this, and we've got each virtual machine, which is going to have its own. Let's build 2 virtual machines here. It's going to have its own CPU, DRAM, that kind of thing. This is the virtual machine, which is pulling physical resources from the server. And then on top of that virtual machine, we'll have the operating system. And then we'll have whatever our other stuff is. We'll call it apps and dependencies. And both systems will have it here. So the concern is, and this doesn't happen very often, that somebody could hack a hypervisor and go from one virtual machine to another. This is the biggest concern. Now, in this particular environment, which is traditional server virtualization, which I'm showing you, this is very rare. And this is a type 1 hypervisor. Now, where this becomes less rare and less scary is, let me show you where this becomes where this becomes less rare and it can happen more frequently is when we're dealing with a type 2 hypervisor, and I'll show you why. So let's say this is our operating system. So now if we have like a PC or a Mac that we're working with, and this becomes it's still call it server, desktop, notebook, I don't care. But now we've got our server, our operating system, and our hypervisor. Where say this is your IBM Note ThinkPad or your Novo ThinkPad or whatever. It could be your Mac, I don't care. And then here's your operating system, Windows, Mac, or Linux. And then you install the hypervisor. The operating systems in many cases aren't quite as secure as the hypervisors. So what can happen in this environment is you can sort of sneak and hack the operating system and go from one virtual machine to another. So that's a virtual machine, like a hypervisor attack. It's much, much, much more common in this situation, like you would have on a notebook computer, than you would ever have in a server virtualization environment. But just to understand that it can happen. So that's a virtualization risk. So another risk is what's called the guest escape. And basically what happens when a user leaves their own virtual machine on, and the user leaves this machine, which has other virtual machines on the same host, and somehow it can get access to another machine, and a user may gain access to the host itself, but it can hit all other virtual machines. So it's not very common. A host escape is pretty rare. But in severe cases, the user could leave the host machine and access to everything on the host device and network, have severe damage. So it's rare, but it's something to plan for. Another thing that we're really concerned for about in the cloud is what's called information bleed. And what can happen here is we can have a malfunction, or we can have a failure, and that can cause data processing on one of the virtual machines to be detected by something else, and we shouldn't have something on one machine being detected by other virtual machines. We could be worried about what's called process specific information. So even if there's not like raw data loss, even detecting the duration that something's running and how long it can be running can provide attackers with access to something else. So we can think of that. We can also think of side channel attacks, which is a type of attack where attackers use whatever information they've captured along the way to narrow down other attack vectors along the way. So when we're dealing with any kind of virtualization risk, we were always talking about data seizure. I briefly talked about it before, where law enforcement can take that physical server and whatever information or that storage and have access to your information potentially, in addition to whoever information they actually also took. Let's also talk about some other virtualization. We can talk about various types of things in the cloud provider. So if we talk about a comparison to the demilitarized zones, we would have a cloud data center is going to be very similar. And it's going to look a lot like, and access to their systems is going to look a lot like a traditional demilitarized zone we would build in a traditional data center. But, here's the thing. In a traditional data center, our demilitarized zones are, here's how you access our publicly facing things, our web browsers, right? For web applications. Here's how you can access your email. But inside the organization's private network, which is 100% firewalled off and not accessible from the internet, is all the internal stuff, the internal data, the internal this, the internal that. You can't just go manage somebody's data center from the internet. But the cloud is all exposed to the internet. You can access these resources for the most part over the internet. So if you hack into that cloud through the internet and you were to hop off various subnets or things, I kind of hope this will make sense. So I kind of hope this typically makes sense and explains things to you. So we're not going to have the same perimeter security. We can't say these two routers connect to the internet and are firewalled off. You can't. And then this can go to the internet, everything's protected. There is no real physical perimeter in the cloud provider. All our stuff sitting in the same data center as everybody else. And it's all accessible via lots of different things. And it's only software protecting us. So for the most part, these threats are traditional threats. It's not like they're new, except that there's a few additional things that are outside of your control. Malware, still a concern on the cloud and off the cloud. Really is. Same servers in your data center can get the same malware in the cloud. Nothing changes there. Now, in a software as a service environment like Microsoft Office 365 or Google Office, hopefully they've done a good job on their infrastructure. Hopefully. But you can't guarantee it. And in your data center, you have the threat that your internal employees do some damage to. And the other thing is what we're actually talking to. So we're actually talking about that is in your data center, you can have a bad employee that hurts you. In a cloud provider, they can have a bad employee that hurts them, which ultimately hurts you too. So just understand these are all the things to think about. So whenever we're dealing with the threats and the attacks, what's the motivation? Why would someone want to break into our systems? What do they have to get? So if it's a bank, they've got a big financial gain, right? What if they're hackers that are trying to hack the secret formula of a brand new multi-billion-dollar drug? There's a lot of financial incentive in that. It could be financial gain. There's this concept of hacktivism, and there's companies or organizations that for political goals will actually hack other organizations to get intel on competitors. People can hack other organizations due to grievances between people. So when we know what threats we're facing and what attackers' motivations are, we can help us plan on how we defend them. Because the forms of attack could be anything. It could be hit them with too much traffic so their servers can't respond, and much of a distributed denial of service attack. It can be a data breach. Systems can be taken down by a bunch of SYN flooding. And, we're not going to talk about engineering here, but those are the kind of certain things. Well, maybe we'll talk a little bit about them, but from an architect perspective. Mark, I might need to stop there for a few minutes before I get into certain types of attacks or some more things. How long has it been, Mark and Chris?
Yep, we can go ahead and take a couple of questions. It's been a little over 25 minutes since we've done so.
Okay, let's see which questions we have.
All right, first question is from Kennedy. They're wondering, is the doctrine of data privacy respected in cloud computing? So to answer that question, Kennedy, generally speaking, yes. That particular doctrine is going to be respected in cloud computing and cloud service providers. And for those that don't necessarily know what Kennedy's referring to, he's basically describing the approach that you're going to learn throughout the entire CCSP bootcamp from beginning to end. But this basically has to do with this idea of embedding security into the design of an end-to-end system. So it doesn't matter if we're talking about just virtual machines or if we're talking about some type of logical network control system, whatever it may be, we're looking at it from the perspective of security and privacy from the initial onset of designing a particular system. To give you a little bit more information in regards to that, Kennedy, you will have to make sure, though, as well with the providers, that they're actually following through with this. So this will also include any third-party providers you're using. For example, if you're using a third-party firewall, not someone that's provided by a cloud service provider, guess what? You'll have to double-check with them to make sure also that they're respecting data privacy as well. And additionally, for those that are in Europe, when it comes to the GDPR, it is actually required as part of that regulation that you design your systems with data privacy and data protection by the start. So just a couple of things to keep in mind, but yes, it definitely is respected in cloud computing. Yeah, let's take a look at the next question. So this is from Scooby. They're wondering, with such an assurance from a cloud provider that your data is backed up and always available to the company in the event of such a hold or confiscation, as you've outlined, it is our responsibility to design the mitigation accordingly and communicate with relevant business associates. And then it says that's a question as to expected conduct and response of an architect.
I don't understand the question, Mark. Do you?
Partially. What I would tell you here, Scooby, is yes, it is the responsibility of the architect in case something doesn't work out with a cloud service provider to make sure that you can put processes in place to guarantee that your data is going to be available. Part of the CCSP is going to touch on a lot of that. Part of that is going to be in regards to, as an architect, that you have to run risk assessments. Because in case of, let's say, confiscation of your data for whatever reason, which generally happens for a reason, right? Then there's a specific reason that you also need to do this. But to make this is a long story because encapsulates basically in the CCSP, because we got to talk about design mitigation strategies. We also got to discuss regards to how do you develop an incident response plan and communication with business architects and stakeholders. But in either case, if you do your job right, then 99% of what you just described, especially the confiscation, is never going to be a worry that is going to come your way.
And you have to present the executives of that business the opportunity. Okay, I understand these assets, these risks. This is the strengths, weaknesses, opportunities, threats of this solution versus this solution. That's the business piece. Absolutely.
Yep. That's also where we get into business continuity planning. I'm a little tongue-tied, but yeah, there's a lot that goes into this. From Lanre, there was saying, I just realized one needs to have basic understanding before one can join the program. Otherwise, one will be battling with elementary while they have is 70% gone.
So I'm
Lanre,
not really
exactly.
sure what you mean by that. So it could be people speaking about our actual architect programs. So let's talk about that. If it's someone that's talking about our architect programs, well, let's be fair. I have 1,000 hours in our architect program to start someone from the deep and very beginning and get them to a point where they're going to be good. Here we only have 30 hours. So we have to make some assumptions that you know something. Had you been in one of our architect programs, there would have been hundreds of videos explaining tech fundamentals before we could ever get to something like this, along with required reading lessons and so many other things for you. So there is that if you're talking about our main architect programs. If you're talking to this, about this, everything we've touched is pretty much your framework for security. And the way I would do this, the same way I would approach any certification, the CCIE, the CISSP, the CCSP, is this. We're going to cover the whole spectrum of what that is. But we're not going to have enough time in only 30 hours to go spend time on each one. I would dive deep in each one of these things. And that's actually how you go deeper. The CCIE itself, when I did that, the people talk about the challenge. The challenge is these are all the things that are on the list, and you have to know them inside and out, and you have to be able to deliver under stress, and you have to be able to not just know the information but apply it. So the only way people pass that is they take something that covers everything, and then they start going down each one. So no matter what the case is, but some of these things, if you don't understand various things of internet protocol, go out there and go work on those internet protocol fundamentals and things like that. But use this as a framework. But no matter what, don't ever get discouraged. You can do literally anything. Yeah. And I'm also going to tell you this, whenever you get involved in a big career change, you're going to go in, you're going to walk into a presentation or a class, and you're going to feel overwhelmed. And it's going to feel that way for a little while. You know what you do? You go back and watch it again, study again, watch it again, learn it again. And here's what happens in all big careers. There's what'll happen is you'll be overwhelmed one day, overwhelmed one day, overwhelmed one day. And then one day you're going to wake up and somehow all these little lessons that you learned that are all about all these things that seem unrelated, the pieces are going to fit together. And I can tell you it's happened to me multiple times. When I first learned to practice internal medicine, here I've got a pharmacology class going over here and a pathology class over here and a physical assessment class over here. And it was like, none of it made any sense to me. I mean, I was learning stuff. I was getting good grades, but it didn't make sense. And then one day it was, okay, this impacts this, which impacts, it was like overnight. Same thing happened in networking. I don't even think it was before I passed the CCIE. I'm telling you, I did the CCNA, CCNP, CCIE in about 9 months. Really didn't know much about networking. And then one day, about a year later, it was like, that's what this is doing. That's what this is doing. This is all how it fits together. But no matter where you start, I promise you, if you tie effort, focus, and love to it, and you apply the right training, where you will find yourself, and yours is incredible. So stay in the fight, do what it takes, and love what you end up with. That's what I would say.
Yep. All right. All right. It looks like Chris from go back to that one, Chris. We'll address it. So TY says, is this the same thing as VM sprawl? TY, I am not exactly sure in which context that particular question comes from. Definitely when you're talking about virtual machine sprawling is where you can't really control the creation or provisioning of virtual machines. That could be due to many things. I always like to call it, because I've experienced this in real life actually, is something we call shadow IT, where you have people doing things without getting authorization to do them. And then the next thing you know, you have changes implemented, things new provisioned that nobody ever knew about. So that could be one of those aspects. Now, if you want to put in the chat in regards to what context that particular question came up, maybe we can give you a more specific answer to that as well. And while you do that, I just wanted to add a little bit more to the last question that we had in regards to almost what you feel is like prerequisite. With anything you do, my personal experience is when I went through the CCIE, I had over 500 hours of video training. I spent countless hours labbing. And I read more than I've ever read in my life before. And I can tell you this, 500 hours of video did not cover everything I needed to know at the level that was necessary for me to understand this. This kind of brings us full circle to a question yesterday that we answered. How deep do you have to go? That depends on you. I needed the variety of visual, auditory, I needed the hands-on. That was anyway a requirement for a certification, just like the CCA. But the reading was crucial for me because in the reading format, they just allow you to be more verbose in how they explain things. You can add images. It's very similar to when you look at how a book gets adapted into a movie. There's a lot of details that sometimes they have to leave out, or they have to take creative, what do you call that?
Creative
liberties in how they translate it. So it's the same here. Sometimes you will need a little bit more than others, and sometimes they will need a little bit more than you. All right. Do we have any further questions? I don't see that TY said something yet, but we'll take the question from Scooby, or he's making a statement. Presentation skills to business associates seems quite important. What would you say to that, Mike?
Well, I'm going to actually call out the word associates. And here's the reason. So generally speaking, in the US, associates means junior level people, whereas architects, our communication is predominantly with executives, the people that have the ability to say yes to the decision. So we're not about how to communicate with regular people. We have to communicate the way we would configure it to the chief information officer, to the CEO, to the chief financial officer to get their justification. And at the same time, we still need to be somewhat relatable and be able to communicate to technical teams. So yes, to some degree associates, but it's much more a communication with executives, the people that actually make the decisions in our world.
Yeah. You could say that presentation skills are a subset of your overall communication skills that you would be needing to actually be an effective architect.
Yeah.
All right. Let's do one more question, and then we'll get back to the content to make sure that we're giving you guys the biggest bang for your buck. So this is coming from Scooby. He's wondering, you stated that it takes approximately 5 years to get tenure after passing the CCSP, and you will be an associate at that point. So achieving the certification now is the best strategy, correct?
I would. So, here's the thing. I'd much rather tell somebody, I actually took a test that was so hard you needed 5 years to be able to pass it, because I wanted to learn from the best and be the best and not hold up my education based on something arbitrary. Then take a junior certification that doesn't require 5 years for you to say, I got this junior thing along with 10 other million people in the world, and I haven't learned enough to really do anything with it. And it's not going to get anybody to really want to talk to you either from a hiring manager side. So for me, I don't do junior level certifications. I do certifications that build my brand, certifications that make me realize how much I don't know. And then I try to dive deep on every one of those things that I don't know and get better at them. That's how I do things. So, for the most part, that's what we're really talking about. I'd go out there with the big ones. It was interesting. I got my first job when I had no experience, but I did have a couple of professional certifications, but that didn't get me hired. But I got hired as a senior engineer, was a lead architect in 3 months. Past that CCI, I realized exactly how much I didn't know, but at that point I was working on Wall Street, and it was like, oh, this was the scariest time because I had to do the most learning in my life. I learned so much. I absolutely loved it. And, each year was just a growing experience, and it was really great. So, the key is we all do what we do. It's just a starting point. But for me, I'd rather aim high. I'd rather shoot high. I'd rather do the stuff that no one's willing to do. Because when I review a resume, I'm not going to look for something that's the average. I'm going to look for whatever's the extraordinary. I'm going to look for whatever that person did. Maybe they were a professional athlete. That's an extraordinary. Maybe they had the golden gloves in boxing. I don't care. Maybe they were a champion football player. Maybe they have an MBA, whatever they have that's going to look interesting. So I look for interesting stuff that maybe tells me something about them, and then I interview them to see what they can actually do. So I look for big stuff.
And it looks like we got clarification to our question earlier from TY. He was actually trying to understand what is the correlation between VM bleed and VM sprawl. So to let you know that TY, when we're talking about VM bleed, we're talking about a security vulnerability, something that eventually you want to fix and somehow mitigate. When we're talking about VM sprawl, this has more to do with the proliferation or how you manage your virtual machines in your environment. So the mitigation for both is going to be very different. One, you actually have to apply some security to it, while the other one is going to have to do with if you have some type of lifecycle management system in place when it comes to virtual machines. And that can include anything from training people appropriately, not just to spin up virtual machines, having change management in place, and so forth. But they're going to be two distinct, separate entities. One is a vulnerability, and the other one has to do with how virtual machines are being created, almost what seems like out of thin air because of how easy it is to create them. Okay. I know we said this was the last question. Mike, did you just briefly want to address Scooby's question in regards to if we as architects need to draft white papers?
Oh, yeah, we do all the time.
Okay. Right. Fantastic.
Pretty much anything you can think to do that doesn't involve touching the technology, we do.
Okay. Fantastic. All right. With that, everybody, if you can let us know that we have a heartbeat, a keep alive message for those that are a little bit more familiar with the tech side. If you can put the hashtag in the CCSP in the chat, we would greatly appreciate it. And then once we see that kind of trickling in, we'll let Mike get back to the content to make sure that there's a lot more exciting things for you guys to take in.
Okay, so yeah, give us that hashtag CCSP so that I know that you're awake, on alert, and oriented, and we will get back to the content. So the next type of attack, which can occur on the cloud, off the cloud, but is potentially easier to execute, is a man-in-the-middle attack, and we'll talk about why. A man-in-the-middle attack typically comes from the spy world. So if I have two people, if I have Chris, if I have Mark, and I have me, and if I am trying to talk to Chris and Mark pretends to be Chris, I could be giving Mark information that's destined for Chris. Now, in the spy world, this worked really well if the person you were supposed to meet, you never met before. So if I was supposed to talk to Chris and I don't know what Chris looks like because I've never seen him in person, Mark could impersonate Chris. Okay, that makes sense to everyone, right? Now, if I've seen Chris before, Mark can't pretend to be Chris because I know he's not Chris. So hope that makes sense to you. As we go distributed and further out, it becomes even easier for someone to pretend to be someone else. And in the risk of the man-in-the-middle attack, if I connect my browser to the wrong page, thinking thinking I'm going to Amazon, but I'm really going to Catazon, but it looks like Amazon, then I'm putting my information in the Catazon credit card website versus the Amazon website. And if there is a Catazon website, I just made it up as we're going along, tried to add the word cat to anything. So please, no harm. But, that's really what we're talking about. That would be a man-in-the-middle attack, somebody else pretending to be somebody else. So that's the risk of acquiring data. But as we go to further and further distributed clouds, we've got more and remote connectivity. It's going to make it harder. So we're going to have to use encryption, and then we'll talk about identity and points to different types of encryption as we go through. We also have to think about loss of devices. So in our own environment, in traditional IT, you basically have your own managed systems and you hand the employees their notebooks. And on those notebooks, you have a various form of a notebook. You've got a various form of the operating system. You've got a couple golden images for your systems for everything that everybody's receiving. They're all locked down, certain patch levels, certain anti-malware. And somebody tries to plug into your network, and hopefully your systems don't allow them on if their systems aren't secure or they have the wrong MAC address. When people started migrating to the cloud, it kind of became a lot easier to just host the systems on the cloud and tell employees to bring whatever device you want. Bring your Mac, bring your Ubuntu Linux thing, and just come inside of the environment. So now we've got more devices connecting to things. We've got our own mobile phones. So that's my cat Cindy, by the way, on the phone. But we've got mobile phones which now have data, and you steal the data, you access my mobile phone. Now, there's various mobile phones and various operating systems and various vulnerabilities. So bring your own devices adds a lot of risk, especially if information is stored on these devices. Now we have to think of regulatory risks. Generally speaking, in private clouds, they're more predisposed to regulatory risks. And here's the reason why the public cloud tends to be a little better here. Big cloud provider, lots of money, army of attorneys that can make sure that everything follows everything it's supposed to be. Big business, enterprise business, they can afford that big army of attorneys. Small business, they may not have the funding to pay the attorneys what's necessary to even be able to interpret some of these standards or regulatory requirements. So they're going to do the best they can with the knowledge that they actually have. And small environments, even though they can be secured more, could potentially not be compliant standards. So think about that. There may be a difference between what's needed for compliance purposes versus what's needed for maximum security. And don't assume that a standard and maximum security are going to be the same thing. Now, we also want to think about natural disasters. So that's going to be any kind of risk that we need to have. Cloud operations are prone to disruptions from natural disasters if they're not managed properly. If they're managed properly, it should never happen. There was AWS had one of the most ridiculous failures I've ever seen in my entire life. They had a data center whose power failed. And apparently the redundant power systems didn't kick in. The generators didn't kick in. The batteries didn't kick in. A power failure took down a lot. So that should never happen, but it could happen. And you have no control. So whether it's a hurricane, a flood, a wildfire, or tornado, should be that the cloud providers' data centers are built better than yours, so they should be more immune to these kind of risks, but that doesn't mean necessarily that they will be. One thing is definitely here is that it becomes much harder to maintain policy when we're dealing with the public cloud environment, because our ownership and where our data is going to be distributed further apart. Loosely coupled architectures often on many different parts of the environment versus in your physical building. So we might make it easier on the cloud to come up with a policy by using cloud access security brokers for centralized policy management, because that's going to make it easier for us to deal with these more distributed environments. I think we probably talked about the risk is lack of physical security. You have no control over the physical security in the cloud provider. If they do it right, great. If they don't do it right, that's one thing that we just have to think about. We can't guarantee that they're going to get it right. You can't guarantee that your own business will get it right though either. So one of the bigger concerns is just this lack of audit access. You can't audit them. You can't go in, you can't check it, you can't see it. And how often are you comfortable with knowing something else? The way it works. Maybe you are, maybe you aren't. Now, here is a bigger threat in cloud computing than in traditional, and that's the rogue administrator. If I've got a bad systems administrator in my data center, and they want to cause harm, I've got more physical controls I can do on that network to lock down and sandbox them to what they're able to reach. I lose all those on the cloud. So the only thing I have is identity and access management. I might have an administrator that's got a lot of access to a lot of things. And in the cloud, they can break a lot of things for me very fast. A rogue administrator could, literally speaking, install 50,000 virtual machines like that on a script and potentially spend tens of millions of dollars overnight. A rogue administrator could do what happened at Google, and this was a mistake, not a rogue administrator, but delete a $240 billion hedge fund, or delete an entire organization's cloud account and take down their entire systems. Privilege escalation is always an issue, always, but in your data center, you're going to need privilege escalation on the switches. You're going to need privilege escalation on the routers. You're going to need privilege escalation on the hypervisors. You're going to need privilege escalation on the systems. If you escalate privileges in the cloud, you may get access to the ability to take too much stuff down too quickly. Now, that's going to all be based upon how well that organization's governance is and how well their policies are. And if you don't pull people's rights fast enough in the cloud, like if someone leaves, for example, or gets fired, and you don't pull their rights, if you don't pull their rights in their data center, they can cause damage. You don't pull their rights in the cloud, they can cause much more damage, because so much of the stuff can be added and removed so simply. Another threat is contract failure. In many cases, contracts can be set up with vendor lock-in, or can have unfavorable terms for the customer when they go to the cloud provider. So this can be perceived as a significant threat. Honestly, this is not something to worry about. The organizations, when they're going to start doing business with cloud providers, should have these contracts reviewed by their own attorneys and have their attorneys negotiate with the cloud providers' attorneys back and forth until they get what's done is necessary. So now let's talk about some risk mitigation strategies that can help address these. We're going to discuss the more common ones. So how do we address malware? Well, we used host-based malware, network-based malware, and anti-malware applications and agents. So we put malware protection on our servers, on our workstations. But we also use next-generation firewalls, like the kind that come from Fortinet and Checkpoint and Cisco and Palo Alto. They can literally scan the incoming messages from malware and block it if there's a problem along the way. We want to constantly monitor our networks and see what's kind of going on. Maybe there's a worm on the network and the worm is spewing traffic. Maybe we can block it with an access list. Maybe we can rate limit something, for example, based upon where we're actually at. But the key is we've got to protect against malware. That means patches, it means updates, it means anti-malware software. We have to protect against internal threats. How do we deal with this? Well, we run highly aggressive background checks on our people. You want to work in a bank environment, you're going to get fingerprinted, you're going to get FBI background checked. They're going to run you through every kind of check known to man, because what you're working with, and it's a highly regulated environment. You want to work in healthcare, they fingerprint you. I got fingerprinted by various states because of a medical and a nurse practitioner license, medical license, other license. You're always going to get fingerprinted. So there's that, because of what you can actually do. So you protect against threats by really background checking your people. You make sure that you have separation of duties so that not one person is able to do everything by themselves. You rotate people so that person in that accounting department that could have been embezzling money won't be able to do it, knowing their job's going to be rotated by somebody else next year that can find it. Not that anybody in the accounting department would be the ones embezzling. They're typically the ones that are finding all the problems, but you get the point. Sending people on a mandatory vacation so you can find out what stuff is going on when they're not actually there. Having two-person things where Mike and Mark both has to turn a key at the same time. Same kind of thing. So these are some of the ways we protect against internal threats. I hate to say it, but organizations need to surveil what people are doing and mask data to limit access to only those that know it, to implement strong egress monitoring. And guess what? They're not going to say it in the exam, but if your employees are happy and your staff is happy and they feel appreciated, chances are they're going to be less likely to attack you. Something to think about. So, external attackers. Now, how do we handle them? Well, we got a lot of stuff we can do here. So, can we block the external attackers at the edge of the network with a firewall? What about a firewall, an access list, a host-based firewall? Lots of stuff that we can use. What about our devices themselves? Our virtual machines, what do we actually need to do? So, if our virtual machines are, for example, let's say we've got a virtual machine. How do we lock that down? We have to remove unnecessary things from the operating system, like unnecessary packages. We've got to shut off unnecessary services. We've got to install that host-based endpoint protection, that anti-malware, that host-based firewall, that host-based IDS, IPS systems. Those are the kind of things we're going to do. So maybe we use security controls from cloud access security brokers, strong IAM policy, strong data encryption strategy, strong network security, strong physical security. There's all these things that get together that we're going to use. And honestly, we're going to make it like an onion where each layer of security you peel back, there's something underneath it. Another thing we want to use is we want to use encryption. And this will protect against things like man-in-the-middle attacks because encryption is going to help me identify who the endpoint receiver is. So if I need to communicate with Chris and Chris has either a key ahead of time or a certificate on both sides, and I need to communicate with Chris, and there's something that means Chris and I can verify that we're actually talking to each other, that's going to help prevent against man-in-the-middle attacks. So we're using encryption, typically speaking, for three reasons. One is if I need to talk to Mark, I need to know that Mark is who he claims to be. If I'm using encryption, specifically IPsec encryption, I don't want you to know that I'm talking to anybody, but that's neither here nor there. I also want to make sure when I use encryption that not only is Mark, but my message hasn't changed along the way. And when I use encryption, I want to make sure that the message can't be retracted or after the fact. It's called non-repudiation. So we're going to use encryption everywhere. Prevent man-in-the-middle attack. I talk to Mark. I know it's Mark and nobody can hear me. That's preventing a man-in-the-middle attack right there with encryption. Another thing we need to think about is social engineering. People really want to be helpful, as most people are good-natured and would like to help others. So it's very easy for an attacker to craft a message and build a pseudo rapport and get there. For example, I actually saw people do it, and I've seen it done to both men and female, and I've watched it done. It's hilarious. You get a very attractive girl who goes up to the guy that's the receptionist, and she says, "You look nice today. You've been working out. You look fairly muscular. You know, I'm from IT, and I've got to go do this." And the guy will say all kinds of funny things. I've seen guys go up to a girl and comment them on their hair and their handbag, and the next thing you realize, we're given the password to a computer. Social engineering can be anything like that. So, social engineering, how do you protect against it? You teach people what to look out for. Lots of examples of social engineering and hacking, but some of those things are things to think about. Now, what about data loss and theft? The first thing you want to do is make sure your devices are encrypted when they're stored. Here, my phone, let's pretend this is a hard drive for a second instead of a phone. I lose the hard drive, I drop it, it's gone. Somebody picks it up. It's got encryption on it, and you know what they've got? Nothing. Nothing that I need to worry about. We're good. So no stress, no problems, no challenges there. So we encrypt it. Generally speaking, I'm going to put some physical isolation controls in place. Should I let you be able to plug into a USB port and pull information? Should I even have that USB port active on your system in the first place? Because if you can't plug in a USB drive, it's going to make it one step harder for you to pull information off, especially if I block your network access. So when we have organizations and they use USB drives, they need to build a plan. They need to either limit them or they need to keep track of them, and when they're done with them, destroy and disable them, and maintain an inventory control. When a business has a computer that's out there, or an employee has a phone, a business must have the ability to remote wipe that computer. So I found that you've got some kind of trade secret on your phone. As a business, I need to be able to delete what's on your phone. So now think about that from a perspective. You may need to purchase the phones that the people actually have and limit what devices are on your systems. Let's talk about regulatory violations. How do I protect against that? Well, for one thing, I have lawyers on my team that actually understand regulations and not pretend that I can be a regulation expert in amongst other careers. Consult with general counsel of the organization for system planning. Use information right management solutions, and make sure that your data is either encrypted, obfuscated, so you can't figure out what's there, data is masked, that kind of thing. How do you protect against natural disasters? Well, for one thing, don't have any single points of failures. So, what does this mean? It means don't have two data centers in the same zip code in a hurricane floodplain in Florida. Don't do that. Now, maybe you have one data center in Florida. Maybe you have another data center in Columbus, Ohio, far enough away that you're not in the same weather thing. So you might do something like that. So no matter what, you need to have a plan around your people, a plan on where your people could work should something happen to the office, a plan on the technology systems that can help that organization deal with it, a plan for everything. Another thing to think about is loss of policy control. So an organization may have to adhere to certain policies. And how do they make sure they do? Well, if they're dealing with a cloud provider, they've got they should put in some strong contractual terms. And hopefully that's enough. At least that gives that organization something to go after a remedy should a breach occur. So also, whenever possible, you're dealing with vendors, you want to conduct detailed audits, or at least to the best you can. And if you can't do it, can a third party that you trust do it? As far as loss of physical controls, there's countermeasures here, physical controls. So things like device theft. Physical controls could mean guards, armed or unguarded. It can mean fences. It can mean turnstiles. It could be dogs. Lots of physical controls we can put in place. If you can't audit your providers, you can come up with contractual terms that they owe you a certain amount should something ahead of time. Again, this is going to be negotiated by your legal team. What about that rogue administrator that we talked about? That administrator that could potentially take down all the systems on their own. Now, how do we deal with this? Well, we apply controls to make sure that nobody has that many privileges or rights. And we constantly log everything that occurred when it happens. And we have good backups of our systems in case something had happened. How could we put it back together as quickly as possible? We monitor things. We monitor the finances. We're monitoring. Another concern that we have, another attack, and how do we mitigate it, is what's called the escalation of privileges. That's where you log in as a regular user, and the next thing you know, you've got administrator capabilities. So here we need good access controls and good authentication tools. We need to regularly analyze SIEM logs to see what's going on, making sure that it's just one person using a user's access, where they're at, what they're actually doing. Contract failure, what's the countermeasure to a contract failure that you have? So consider, at least no matter what, backing up your informations on another cloud or another data center. Make sure whatever your systems are backed up on is secure, either via trusted third party or your own. Keep, under certain cases, things in other places should you have a problem with a vendor or a provider along the way. How do you mitigate the legal seizure risk? Well, you encrypt all data that's going to be stored in the cloud. And you'll employ various forms of data dispersion to spread data across multiple locations. So if you access just one thing, you didn't get access to everything or the entire systems for a business. Anytime you're dealing with a business impact analysis, you need to think about that, plan that. Should it occur, what will be the impact? And that should be part of your business impact analysis prior to designing any security things. But you should consider, and by consider, I mean do use encryption on any data that's actually stored. Okay, we're going to actually start to begin on talking about disaster recovery planning. Let me just check and see where we were with them. Okay, I think we should. Mark, how long has it been? Because this is 23 minutes. Good. Let's stop here for questions because.
All right. It looks like we did have a question from Scooby. I was looking for a little bit more context in regards to that, but if you want to pull it up, Chris, unless there's something that perhaps I'm not understanding, maybe Mike can draw from it. Let's see if we can address it. All right. Looks like he also answered. It says, "Is your credit, if your credit is lowered, is this still a viable career path?" And then let's take a look at the second part. He's saying, if hospital bills exceed the insurance of someone who hit me in a collision, and I see my credit score dwindling, could this discourage larger companies who hire for this role?
Generally, no. Your credit is typically not, and I'll have Chris explain it from an HR perspective, but typically not. Typically speaking, I'm the manager and I'm actually going to be looking for the attributes of someone that can do the job and someone that I can like. And that's typically what I'm looking for. Chris worked in HR for about a decade, so he can tell you the HR perspective in addition to the hiring manager perspective. Chris?
I'm trying to get my camera to work. Can you guys hear me?
Oh. Yeah.
Okay.
Loud and clear.
Sorry, I'm not used to being on the front end. So, okay, my camera's not being recognized. Yeah, so from we actually have a lot of people ask this about different roles just in general in any industry and any career, because they know that there's background checks and there's things of that nature. So usually credit or financial background checks only come into question for people that are directly related to money. So like your comptroller, your accountant, your auditor, your things of that nature. And even at that level, what we're looking for is we're looking for people that may be in a position of undue influence or undue stress, like maybe someone that has 10 times their annual salary and outstanding debt that's not secured. Like, things that look scary, look very scary, and would show an employer that, hey, this person might be a liability. But that's less than 1% of positions out there. And that would not be architecture positions.
No.
Until you get to a certain level. And again, we're talking about the 1% of the 1%. So I guess that's 1/10% or a 100th% of the position.
Yeah,
so usually, credits, especially if they're related to healthcare or anything of that nature, it's usually just like, nothing to worry about. But we do get asked that as HR people, we get asked that question a lot. So, so I'm glad I had the opportunity to say that. So 99.9999999% of people don't need to worry about their credit when they're going for employment opportunities. So
yeah.
So, but I'm glad they asked that question. Let's see what else we got here. I'm going to go back off camera now, where I'm much more comfortable since my camera's not even working.
Fair enough. And just to add a little bit of additional context, this is all a measure of how much they can trust you.
Yes.
So that's really where all these measurements comes in.
Exactly. Yeah, that's.
I'll give you two examples. One of them is not architecture related and one is architecture related. So a long time ago, I had the bright idea. This is Pup Mark that decided, you know what? I like the idea of security systems. I wonder if I can make money with this. I ended up finding a company that was installing home security systems. And I was giddy, right? Because you have to learn about how to program the different home security systems. I had to run cabling. I had to also educate the customer on these things. So again, nothing architectural based, something completely off base. But when it came time to actually put an ink to paper, I got the background check. And included in the background check was not just my credit score. They also went much deeper into finding out what my personality was like. So I had personality tests. My credit score, as I said, was taken into account. I had to get fingerprinted. So that was an additional measure that I had to do. Of course, drug testing was normal. And I asked them, says, guys, this is a little odd to me. I've never gone into a job before where I need to do these things. And they told me, well, Mark, you're going into homes and businesses. There's going to be many valuables around. It says, like, from your perspective, how would you test somebody as regards to how much trust we can have in them? Once it was proposed to me that way, it made a lot of sense that they needed these different data inputs so they can build a trust score in regards to if I was employable or not in that sense. We have a very similar type of procedure. And while the CCSP doesn't touch too much on it, every cloud provider to one extent or another actually does implement this zero trust architecture. And part of that zero trust architecture in security is what we call a trust score. We take many different inputs to build up a trust score that will tell us inherently how much can we trust this person. And this is malleable, of course. But that just gives you a little bit of an idea how these various things can be put together just to test your trustworthiness. That doesn't mean every job can do that to you.
And it could be based upon the role. For architect jobs, it doesn't typically affect us. In fact, I can tell you almost the exact opposite is true. One of my first managers said this to me. We had gone out to lunch. He dropped me off at my home, and I'm like, "Come on in." And I poured him a Macallan 25, a really nice scotch. And he looked at me, and after he had the scotch, he said, "Mike," he said, "something about you makes me a little less secure." He says, "You got a house, you got a car, which doesn't look like it costs you anything per month." He's like, "You're portable." He says, "You got nothing weighing you down, do you?" And I said, "No, I love what I do. That weighs me down. I want to be better." So to some degree, people actually like knowing that you're stable, that you've got a mortgage or you've got something. And there was actually a movie about it called Picture Perfect with Jennifer Aniston many years ago. She was single. They had to have a fake husband and a fake car payment and a fake house so she could get the bigger promotion. So no, they're not going to be checking your credit scores as a general rule. They're going to be checking you, potentially a background check. In most cases, they no longer do drug testing, although they could, but in most cases, they no longer do. And it's more about, can they like you? Can they trust you? Can you do the job? So that's going to come more from your interview. But if you were going to go to people's houses in a visiting nurse environment, that would be totally different, just like Mark was describing it, but not for architect roles. Yep. All right. So let me get back to the actual content we have over here because I didn't see any more. Please give me a hashtag CCSP. So let's briefly talk about some disaster recovery and business continuity planning. And this is going to be very applicable to this exam, but it's also going to be, there for everyone. In any environment, must always create a business impact analysis. And we're going to have to create a business impact analysis specific to every cloud platform that we use. We are going to have to establish shared planning and shared planning responsibilities, because in the data center, we can plan just our stuff. In the cloud, we can't plan on what they do and when they do it. So there is that, but we still have to get them involved to as much the degree as we can. So specific to your business impact analysis, and to some degree we talked about it in the beginning where we talked about, the annual loss expectations, those types of things. We have to evaluate the business and see what changes for the cloud and how do we need to change this. What new risk do we have with the cloud, meaning a shared thing that could get hacked? But what new opportunities does this create for us? Does it create more agility, and how can that business leverage that agility? If we block everything for the purpose of security, nothing will ever get done. So it's all about that balance. So let's think of things that can impact us in the cloud. So if we have a campus and a data center, there's no wide area network. So as long as the campus is up, we're good. If we have to attach if our systems are in the cloud and we want to attach them securely, meaning through a private line or an IPsec tunnel or a software-defined WAN or a SASE WAN, we need the wide area network service provider that we have. So if the wide area network connection goes down to the systems on the cloud, we can no longer use them. So now we're accessing things over a wide area before we're doing it over a local area. There's more to go wrong. There is no cloud computing or access to systems if your network goes down. So 2 networks if you're going to use cloud computing minimum that you need backup to them on 2 different companies. So now with the business impact analysis, things you should consider is now you're dependent upon others. So you're dependent upon them to do their stuff when they say they're doing it. So is that provider going to be able to meet their obligations? Is your provider dependent upon other vendors, which they are, and can they do their thing? So, there's all of that. What happens if your cloud provider doesn't meet the regulatory obligations? Unfortunately, you're still responsible for them. So you have to think about this in your business impact analysis and how you'll plan for it. So let's think about what happens if there's a data breach or an inadvertent disclosure. The risks of this happening in the public cloud are greater than in your data center because there's now 2 parties involved versus 1. It used to be your internal personnel, but now it's your internal personnel, the cloud personnel, and that wide area risk that you have. So the legality and the liability cannot be transferred to anybody else. It's on you, even if the risks are if somebody else is hosting it for you. So what does that do? Now you have to reassess the impact of information disclosure, for example. What about the cost of a data breach? What is the cost of that? And, that's something you have to plan on. So typically speaking, it's $150 to $250 typically per person you have to notify that there's a data breach. So we had a healthcare insurance company that has to notify 100 million people that they've been breached. And the typical cost of that is about $150 per person. 100 million people. Now that health insurance company gets fined from the government because they were attacked. Because, of course, if you're attacked, you're going to get fined. So now they have to worry about that. These are hard costs to that organization. What were the costs that doctors and hospitals couldn't negotiate with each other for a few weeks? Again, hard cost. Non-hard cost is what is the reputation of that insurance company after this happened? Who trusts that insurance company after this happened? That kind of thing. So let's talk about vendor lock-in and vendor lockout. This is a real risk. And this can easily be done. So what happens is the business needs to run these cost-benefit analysis or SWOT analysis, or where they're going to look at all the opportunities gleaned by these various proprietary technologies and say, does it make sense to use this? Or should we prevent ourselves from getting locked in by using open standards, etc., and not using any of this proprietary stuff? And if so, what do we gain? What do we cost? Now, when it comes to disaster recovery planning, there's lots of contract negotiation stuff here, because how do we address the needs for the service? How do we address policies? How do we audit stuff we can't audit? And understand, when you put your systems on the cloud and you want to test them and hardcore penetration test your systems to see if they're going to hold up, you can't even test your systems to the same degree on the cloud because your cloud providers won't let you. You have to get some permission ahead of time, and you'll be limited at how hard you can actually attack your systems. So if you can't even test your systems to see how secure they are, you can't be assured that they're as secure as if you could in your data center. So all these little nerd knobs, as we like to talk about in the BGP world, tune this, gets you this, but it will cost you this. Everything has an impact on something else. It's not what's in front of you. That's why architecture is not engineering. It's the implication of this thing over here and what it does here, here, and here, and here. And as you can see, this stuff just keeps building and building. So there's basically 3 or 4 styles that you could use for the cloud to back up. And we're talking about practical things. So that's what we're actually talking about here. So, and actually, I'll get to Togba's question. In the CCSP and the CISSP and any of the professional exams, there's never going to be any labs that you're configuring. These are geared more towards architecture, which means they're geared towards no principle. Architects don't touch technology. There's no labs for actual architects. And that's why, Togba, there's not going to be any labs in this program, the CISSP, the CCDE, or anything that's related to architecture, because architects don't touch technology. So let's talk about the way we can actually, there's options with regards to disaster recovery backup on the clouds. And if we're going to do it, here's the things we need to plan ahead of time. So we can have our primary systems. We could use the cloud as backup, which is something we can do. And if we're going to have primary systems and then use the cloud as backup, what do you think we need to think about? Making sure we keep our data synchronized at all times, having the sufficient bandwidth, what have you. So when we're dealing with this, we're going to have to think about our wide area networking costs between the local and the destination. The customer, in our case, which is us, will determine what our failover criteria is. So what is it going to take to switch over from our primary data center to the cloud? And what is our type architecture? We can negotiate prices, what have you. So always a good opportunity here. The cloud provider can be used as a backup. Doing it this way, it can be done. So actually, let me map out realistically your four architectural options for cloud backup. And there's what I'm going to call, then I'll draw them out for you. Here's what I like to call backup 1. And this can be backing up your data center to the cloud. This can be backing up your cloud to a second cloud. So here's what I call it. Let's say this is your data center. This could also be AWS. It really doesn't matter. Over here, we have Azure. So here's one way that we actually could do this. Option 1 is we take backup images of various virtual machines. So we've got VM images. Well, we've got images of your various virtual machines. We back up your data. So we put the data on the cloud. And if this could be the data center or AWS, but this is one of our forms of disaster recovery. Let's just call this Azure for right now, because we don't really care where it goes. So if a failure were to occur here, and it's complete and total catastrophic, we could have an offline failure where we have our data here and our virtual machines here. An infrastructure as code script is launched, and all of a sudden our virtual machines are up, our data is basically synchronized except for our database, and our systems are up and operational relatively quickly. This is option 1 when it pertains to backup. Now, option 2 is going to be this. Bear with me a minute. And this is even a little cooler. In option 2, what we do here is we've got backups of all of our virtual machines. We've got backup, we've got data, but in between us and the cloud, what we're actually doing, and I should have put routers or switches here before so I'm just going to draw that pipe, but they belong in either case. But now what we're going to do, what's going to be specialty, is we're going to keep our databases synchronized. So whatever databases we have here, we're going to synchronize those databases with the cloud provider. And by keeping these two things sunk up between each other, should anything occur in our data center or cloud, we've got our virtual machines, We've got our data stored, which we back up periodically. We've got our databases that are synchronized. The Terraform script is launched, for example, in Azure, and the AWS and data center infrastructure is recreated. They're basically your two offline architectural approaches. Our third way that we could back these systems up is going to be as follows. In this particular case, we can have, let's just say this is, actually, let's go back to me copy and me take some of these things, and I'll show you the difference. Oops, didn't mean to do that. Enter. Let me come here and paste this in. So in this particular environment, what's a little different is this is what you would call sort of a warm standby. Let's say in our data center, let me just, in our data center, let's say we've got some VMs. We've got some the database. We've got some more app VMs. And what we would do in this situation is we would have the data. Well, let me hold on. We'll keep our databases synchronized. We'll have small versions of all the virtual machines actively and running in the cloud. Like small versions, there'll be an auto-scaling group. Our data will be synchronized. These systems are up and running all the time. Maybe we've got 1,000 virtual machines here. Maybe we've got 10 or 20 over here, small number of them. If a failure is detected over here, traffic gets redirected to the public cloud provider, and all these little virtual machines will have auto-scaling enabled, and over the course of 45 minutes, that other cloud provider will scale out to full capacity and with auto-scaling, and that's typically one of the best forms of actual disaster recovery we can have in cloud computing, and cloud computing made this possible. The last architectural option is, and this is realistically speaking what really critical organizations have been doing for years, but is probably not needed in most cases, is whatever you have in the data center or AWS, you replicate 100% over it here, say Azure. And if anything and it's running 24 hours a day, 7 days a week at the same capacity as what's over here, and you go straight from here, and immediately a failure would redirect to here. Now, I'd like to show you a more cost-effective version that gives you the same degree of availability and to some degree business continuity planning that doesn't cost so much. Option one, put 50% of your systems in AWS, put 50% of your systems in Azure. By normal, put 50% of your traffic here and the other 50% of your traffic here. Should a cloud provider go away? Don't worry about it. It's no big deal because the other cloud provider has auto scaling. And if Azure went down, AWS would just auto scale and you'll be at full capacity and have 50% within 45 minutes, and you'll have 50% capacity to begin with. And it typically doesn't get more expensive. So that's the greatest architectural approach in many cases. But we have to evaluate all trade-offs before we make this. So if we're dealing with our data center and have the cloud provider as backup, this is very cost effective because we don't have a lot of systems running in the cloud. We're only paying for what we use, and we can work around failures very quickly. Now, this is different than the traditional disaster recovery environment where I've got a primary data center, say in Princeton, New Jersey, and in McPherson, Kansas, I got a backup data center that I could use should there be an emergency, which means I'm constantly running systems there. It's in another geographic area that's far away, so it wouldn't be impacted by weather, if you will. And there's just so many other things along the way. So lots of opportunity. Guess what? By splitting the load across multiple clouds in some of these situations, we avoided vendor lock-in because we had to use open, non-proprietary standards. So no matter what we do, we're going to have some negotiation, some dialogue, and a lot of planning between the cloud people's teams and our people's teams. Whatever the case may be, make sure there's a clear delineation between the roles and responsibilities between your organization and the cloud providers. So when do you declare a disaster? So if you've got a disaster recovery plan, the reason you're activating the plan is a disaster, right? So there's a disaster. At some point, the executive part of that business needs to declare an disaster. That's the CEO. You know what happened to me a couple of weeks ago? I got an email from various parts of the state of Florida, and it said Florida is under a natural disaster. And guess what? As a licensed medical professional in Florida, I got another email from the governor. And the email from the governor said, you can now authorize your patients early refills on their prescriptions. You can now do this. You can now do this. You can do all these things under the auspices of an emergency. Because in order to kick off disaster resources, whether it be at the country level, whether it be after a hurricane, or whether it be something else, somebody has to declare an emergency. So the first thing that has to happen, the C-suite declares an emergency. Now, when this occurs, there's going to be a specific person. There's typically going to be a backup of a specific person, because what if the primary person that's responsible for the emergency is in that emergency and incapacitated? So there's always going to be a backup. Now, there needs to be not only a person in charge, but there needs to be a detailed emergency operations plan and training to key stakeholders. So what happens in emergency? Who's activated? 1, 2, 3. Now, senior management will have to come up with the people that are allowed to declare an emergency, because it could be somebody in the factory that notices a fire, and that's a real emergency. So maybe it's the manager, the supervisor, but somebody has to be able to do it. Now, whenever possible, we want to implement a warning system. So a system that warns people of a disaster. I live in Florida. I got to tell you, a disaster is coming. We get every notification you want. We'll get text message. We'll get phone calls. We'll get these emergency alerts. They'll come at you from every angle to protect you from getting hurt in a hurricane, for example. So make sure you've got some good way of communicating this disaster. Can you message your employees? How do you make sure that everybody's aligned? Because you want to protect lives and property, but lives first, the safety of your people first. So both the customer and the provider will have to agree on, what's a formal disaster, that kind of thing. And there'll need to be a preliminary schedule and preparation of formal communication. So here's a disaster. What has to happen? Who notifies whom? Who notifies whom? Who brings in what resources, what to do, and when, and how? All this stuff is architecture. That's the planning. So the timing. So if we have to notify somebody, or somebody has to notify us of a disaster, we need to know when in a certain period of time. Is it 10 minutes, or can they tell us there's a disaster a day later? So we're going to have this. And if we have a failover, is it fully automated between one provider and another? Or do we have to do something? So in our contracts, we will have to specify all these things. Now we're in a disaster. Do we stay in a disaster, or at some point do we go back to normal? There was a hurricane where I was at. There were tornadoes all over the place. Woke up the next day, had no power. Out of nowhere, people are chopping down trees, clearing roads off. 2 days later, it's back to normal. Pretty impressive. I can't even imagine how they did it after this hurricane, but that's kind of what we're actually talking about. So I kind of hope this makes sense where we're at with regards to resuming normal activities. At some point, we have to go back. So what is the process to resume normal activities? We will have to make sure decision makers are aware of the risks and the implications of every decision we make. Every decision we make impacts something else, which impacts something else, which impacts something else. That's why we architects are always focused on strategy, and we can't focus on the deep tech of anything, because you can't focus on the strategy and start thinking what happens when you move this chess piece a further part in the field, how that impacts somebody else and the else, if you're trying to build stuff at the same time. So let's talk about backups. Mark has mentioned to me that it's about 20 minutes since the last time we took a break. So let's stop here, answer some questions, and then I will begin on we'll begin on the next section.
All righty. All right. Now, you already answered Togwa's second question in regards to the practical labs. So we'll take his first question. He's wondering, how do you avoid a cloud vendor-specific lockdown? Do you have the option of choosing your vendor on a public cloud infrastructure? Togba, when it comes to your second question, can you let me know, are we talking about the cloud vendor itself if you're choosing them, or are we talking about an actual third-party vendor? Like, for example, if you wanted to pick a particular routing vendor, firewall vendor, load balancing vendor, let us know in the chat exactly what you meant with that. I am going to address first the how do you avoid lockdown. When it comes to that, I want you to think of vendor lockdown as a trade-off. Basically, the decision you make is going to be a trade-off. And what I mean with that is you're going to look at these different cloud vendors. You're going to find features and capabilities that you're going to think are going to make your organization so much better. They're going to provide some real value. In your mind, you're going to make justifications up in regards to that. If I pick this particular vendor feature, it's going to be able to help my company with X, Y, and Z. And in your mind, you come up with this idea that you're actually balancing out and you're justifying these things. And I want you to avoid that. I always want you to think from the perspective there's a trade-off. Now, practically, what could you do to avoid vendor lockdown? Multi-cloud strategy, number one. If you have a multi-cloud strategy, you're forcing yourself already to make sure that you're going to have portability of your data, or at least you should. Same with security. You should have security that can stretch across all the different cloud providers that you happen to do business with. So that in itself is going to already force you not to pick very specific feature sets or very specific services that will keep you, let's say, on an Amazon or on a Microsoft or on a Google Cloud or IBM and so forth. But something else you can do, let's say you're presented with the challenge that you have applications and for some reason you had the budget, you created your own application so that you cannot have the vendor lockdown. What you can do instead of going down the road and now trying to create like what we call this cloud native application, meaning that you're designing the application so it functions a particular way, the most efficient way on a cloud provider. You can get creative. Just package the application, let's say in Docker. Then use as an orchestration system, use something like Kubernetes. And that way that you can just literally transfer the workloads from one cloud to the other because all of them are going to support Docker. They're all going to support Kubernetes. So that's a little workaround. Now, if you don't want to go down that path, guess what? You have commercial software that you can use. But again, there you have to be a little bit careful in regards to which service provider they do support, or you go the open source way, where you pick an open source application or software, same with like a database, right? You don't pick Dynamo database, right? You go with something like Postgres, SQL, or something like that. You try to balance it out, where you're picking something that you know is supported across vendors. And then something very specific is do not ever, unless there's a very specific business drive or business case, pick an application simply based on its feature. Under all circumstances, avoid that if you can, because you want to keep this in mind. We're talking also about business response, business continuity planning. We talked about portability, reversibility. We've discussed this today and yesterday. What if you have to migrate from one service to another service, from one platform to another platform? I've actually dealt with a customer that ran into that problem. They got stuck on AWS, and out of nowhere, they hired somebody else. That individual did not have the experience necessary to manage the AWS cloud, and they wanted to go to Microsoft Azure. And it was a headache trying to convince them on what is the best path to go about to do that migration, because they locked themselves in with Amazon-specific applications and services. So if you can, avoid that. Now, do you have anything to add to that, Mike? Any additional ones? I didn't want to list out like 30 things that you should be doing.
I think you did a good job. So the key is if you take the things that are in the certification and anything that's proprietary, don't use it and you'll never have a problem. So if you think about going to the cloud, virtual machines you can use, the storage you could use. Don't use any of the cloud providers' databases. Just throw them out. If the cloud provider has any proprietary container orchestration like Elastic Compute Service, don't use it. If the cloud provider has any kind of firewall, don't use it. But that's okay, because who do you think has more experience making databases? Amazon or Oracle? Who's been in the business longer? Oracle. They've been in that business longer than Amazon even existed, let alone the whole Amazon. So, that's what we're really talking about. Who do you think has more features and functionality on their networking? Cisco and Juniper, or a cloud provider? Cisco and Juniper had more features and functionalities in their network back in 2001 than the cloud providers have today. So what we're just saying is use the bigger, more international tools, and then you're never going to get locked in, and then everything you works on both clouds. Now, there might be times where you might want to go proprietary. For an example, I only used the routing protocol EIGRP one time in my entire life. And I always used something like OSPF that would work with all vendors, because everything was multi-vendor. And I had a client, and that client had almost no sophistication technical-wise. They had very few people that actually understood routing, and they said, Mike, what do you want to do? And I actually said, in your case, I'm suggesting EIGRP, and I'm reasoning this because your team doesn't have the sophistication to get deep with regards to interior gateway protocol, specifically diving deep in these link state protocols. I said, if your goal is to hire these people, then I would go this way. If your goal is to run with your current staff, run this way. And we sometimes it's choose the proprietary solution because it may be your only option based upon the people. But in other cases, if you can choose not to, you're probably better off not to.
All right, great. Let us take a look at our next question. And this is from Seiwai, or Sei. And I apologize if I mispronounce your name, but I wonder, what page are we on? We should be on page 157, I believe. Let me give you the title of that. That should be at Cloud Operations and Cloud Providers as Backup. So we'll touch on that once we get back to the content there. So page 157. Now, Claudia is asking, does the exam cover government clouds and China cloud?
No.
No. You'll notice many times when it comes to anything related to Republic of China, that generally speaking, they have specific special legal governance and compliance rules that, let's just say, you want a lot of competent people in those areas around you. Okay, let's take a look at our next question. Scooby is asking, do we use Express Berkeley packet filtering much? We do, but in this case, Scooby, again, it's not something that's specifically mentioned in this part of the CCSP. But yes, depending on who you're working with, this is actually something very commonly used, or a subset of it used in a Linux, to differentiate on how actual interaction is done between the kernel space and the user space. And when you're talking about eBPF, there are certain vendors that have also jumped on the bandwagon to protect applications from injecting things into the kernel that shouldn't be there. And Cisco is one of them that have, I think as of August, they came up with one of the solutions in regards to that. For those that are not familiar with Express Berkeley packet filtering, this is just a security measure to avoid producing unnecessarily panics at the kernel level of an operating system. So this is not necessarily something that you will have to be intimately, and I'll be honest, even at a high level, be familiar for this particular CCSP exam. But if you're interested in it, of course, take a look at Google, do a little bit search in it, and you'll see vendors like Cisco, and especially also in regards to, I believe there's an open source page in regards that discusses more about the Express Berkeley packet filtering.
Yeah, and that's going to be at a hardcore engineering level. My friend David Lithicum, who was Deloitte's chief cloud architect or chief cloud strategist, he likes to say, if I ask somebody and they knew what it was, I know not to hire them for my architect team, because they're going to be too technical and they're going to be focused on the tech stuff versus the business stuff. And we actually look for that in an interview, is not to see that techie. We're looking for that strategist, not the techie. But if you want to be an engineer, it's great.
Yeah.
So
don't answer it the way I answered it on an interview. Yes. That's the lesson here. All right, one more question, and then we'll get back to the content. And this question is from Yasel. They're wondering, what is the most common failover strategy between cloud providers in a multi-cloud environment? And then, do companies run their entire infrastructure or multiple providers, or do they use a second one for backup? Do you want to tackle the first part of that, Mike?
Yeah, so, every one of these has different business needs, and depending upon the business needs will determine what they want. If a business has mission critical high availability needs, meaning they need their systems to be up and operational 99.999% of the time, they're going to have a data center and 2 or more clouds. And they're going to have a good degree of load sharing and network redundancy and seriously in place policy controls. If they're among the 98% of businesses for which their business matters and tech matters, they're going to be using more than one cloud. So one cloud goes, you can immediately fail over to the other cloud. Now, when we get small, and they're going to spread their load in most cases across multiple cloud providers, because I want you to think about it. 50% on one cloud and 50% on another cloud doesn't cost me a lot. 100% on one cloud and 20% backup on another cloud is now 120% of my costs versus 50% plus 50%. So the businesses that have the best architecture are load sharing across multiple clouds in most cases. So they can use a primary and a backup. Now, if I'm dealing with a big bank, this big bank may actually have data centers. They may be on AWS. They may have something else running on Azure, and they might be backed up to a Google Cloud because they're not going to back up to their same systems. And when you get really big and really high availability, that's the kind of thing you're going to be doing.
Exactly. All right, everybody.
And I want to answer that question from Scooby Dell about junior architects for a reason. Mm-hmm. And because I want to protect the people that are out there. There is no such thing as a junior architect. My architects that get their first tech job are hired as architects. There's no doctor on their first day of medicine that doesn't know what to do and is going to have someone teach them what to do once they graduate. There's no airplane pilot in the cockpit of the plane that says, are you going to teach me what to do? This is why we have a cloud architect program when we spend 1,000 hours, because you can't learn architecture by yourself. You can't learn how to fly an airplane by yourself. You can't teach yourself how to be a physician, because unless you've had the role, you won't even know where to begin, and you won't know what you don't know. So on your first day in the job, people are going to expect things from you, and they're not going to guide you. Nobody's going to hire you for $180,000 a year and say, it's time for me to start training you. When they're going to hire you for a position, and pretty much the lowest salaries we see is $150, and we're seeing salaries over $409,000 from graduates we have, you have to know something. So you got to be there, you got to be ready for work, and you got to be taught these things. Because where do you start? Step 1, step 2, and I had it taught, and I took, but that's the key. So it's kind of like a CCIE. It's pretty hard to try to figure out how to do that one on your own. You pretty much, all of us, I had to go to multiple vendors for my CCIE. I had to read 50 books. I had to read, every RFC, and it's one of those things. So don't worry. It shouldn't discourage you. If you get the right training, you can conquer anything. And here's the good news. 90% of the people are afraid to get the right training. They're going to think they can figure it out on their own, and they can't. And you know what happens when you're properly trained and you're capable and you're ready to go, and everybody else doesn't even know what they know or don't know what they don't know and don't even know where to begin? You'll have every opportunity in the world for you. So be thankful for things that are a little more challenging with a bigger barrier to entry. There's no competition on these interviews ever. You can just go out there and get it.
All right.
Let's get back to the concept, because I just want everybody to know there's so many opportunities now. It's just such a great field. All right. So we put in a plan. Has anybody built in a plan, like an emergency plan, and never tested the plan? And when they try to implement it, it's a disaster? Well, I'll give you my own personal experience. So one day somebody said, Mike, do you know how to start a fire with a bow and a drill, a stick and a piece of string? And I said, how hard could it be? And they sent me off to the woods, and they said, Mike, you need to start a fire inside of 4 hours. Well, blistered hands later, there was no fire. And then the person said to me, Mike, let me teach you how to do this. So taught me how to create a bone and a drill, and boom, boom, boom. And all of a sudden, I had a little smoke, and then I had a fire. So my plan, which is I thought I can figure out when I need it, didn't work. I was taught how to do it, and I can do it. So anytime we build a plan, we have to actually test the plan. So we've got to test our backups. We've got a backup process, a backup procedure. Is it working? How do we know unless we test it? So if we have 2 clouds, right? And we want to know if one cloud's going to fail over to the other. Maybe we shut off a networking connection and see what happens. So in order to do a test, we need a plan for a test, right? Because if you don't plan for the test, I promise you, you won't be testing the right thing. And when you plan a test, you need to know what steps you're going to take to start the test and what steps you're going to take to put it together. So when you test your plan, you're going to find so many things that you thought you did right, but you did not. When you test your plan, you're going to test the skills of your people. Can they actually do what they're supposed to do? You're going to test the veracity of the plan. Is it going to work? And these things become really, really important. So how often do you do the testing? Well, there's lots of guidance out there. The industry guidance says in most businesses test once a year. But what if the organization has mission critical operations? What happens if when those organizations' tech systems go down, people die? Imagine like an emergency call system for paramedics, police, and firefighters. Or the air traffic control system. Or a hospital systems where people are undergoing surgery at all times. And thousands of people are coming in and out. Might be a problem, right? Or hundreds anyway. So the testing frequency needs to be based upon the business. So whenever we're going to do a test, you should coordinate it with your cloud provider in advance of your actual test. You should assign specific responsibilities to the participants in the test. And when you actually do the test, you're going to have to detail every problem that you found in the test and didn't work. So first, can you get the business back to normal operations after your test? You're going to have to check that too. But did it work and what changes did you make? Now, when you're dealing with these things, we constantly have to evolve our systems. Do we have something security-wise that when we transfer everything over, like an overly restrictive access list, it's going to break everything? Is there a firewall that needs something open or it won't work? This is going to be a constant process of test, evaluate, improve. Same thing when we design our systems, constantly. So there's design patterns we can look at on the cloud, but new technologies come constantly. Business environments change. New security threats come up. So we're going to have to constantly stay up to date. And that's someplace I promise you, as a security architect or a cloud architect or an enterprise architect, you're going to constantly have to stay up to date. And what's going to make that easy is the better your fundamentals are, not how to, but how things work. The more every new technology that comes out, you'll realize it's just a new version of the same old thing. It'll be easier. So collaborate with your vendors. Collaborate with security professionals. But make sure that it is not a one-person thing. Architecture is a team sport. Get everybody, your network security people, your application security people, your physical security people, get them all working together across your cloud providers, across your security vendors. And when you build your organization, maybe you have an organization that will respond to different enterprise architecture patterns or different design patterns. And depending upon the business, the architects will have to determine the organization structure. And this is more cloud architecture and enterprise architecture, but I just want you to think about this from a minute. It's an enterprise architect thing. Imagine I have a McDonald's. Every McDonald's, for the most part, in the entire world produces the same product, at least in the United States. They're a little different outside the US. If I get a Big Mac in New York, a Big Mac in San Francisco, and a Big Mac in Miami, for the most part, it looks nearly identical. Now, McDonald's does not have the opportunity to make sure that everybody it hires has a PhD or everybody that it hires has 50 years experience in a kitchen. So McDonald's has a great degree of processes, a great degree of procedures, and a great degree of technology that standardizes it. And that way, if you hire Billy Bob, if you hire Sally, if you hire Nico, Maria, Aguilo, or Spiero, it doesn't matter. They're all going to make the same hamburger no matter where they're at. So that's a type of design pattern that's going to favor a high degree of standardization in the system. By comparison, Morton's, this is a steakhouse that I typically like to go to. don't go that often because I don't eat that much rich food that often. But if I go there and I want to get a steak, I can tell them to fillet at Oscar. I can tell them to put crab meat on it. I can tell them I want it medium rare. I can tell them to make it salty, peppery, grains of paradise, which is a spice that I tend to love. But I can have that, put it on. I can make it anything I want, and I can get my broccoli cooked any way I want. So a company like Morton's would have less standardized systems. So we may have a business where we can create a design pattern for various business units, a cookie cutter design that we've determined is best for that business. We may also have to make our various business units completely different, but that's an enterprise architect thing we need to have. But perhaps we can create blueprints. And then there's that. So the next thing that I have to touch, and I'm going to try to do this as delicately as possible, is the cloud providers have some vendor-specific design patterns. AWS has a well-architected framework. Azure has a well-architected framework. Google has the Google Cloud Architect Framework. These frameworks offer prescriptive guidance on how you could design your systems on their cloud. Now, I'm going to say this very gently and carefully. They provide guidance on how you should design your systems without having any knowledge of how your business operates. So imagine if 1,000 people went to a surgeon, and before they ever met the surgeon, they even entered the surgeon's office. The surgeon said to every one of them, "You need this surgery." And it was the same surgery, regardless if the person needed surgery or not. These well-architected frameworks are prescriptive without actually knowing the organization's and client's needs. So they are very good at getting the technology to operate, but they're not necessarily doing a good job of making sure the technology meets the client's business needs. And I can tell you that the data is strong that shows to 70 to 80% of cloud architectures fail to provide business value, meaning they don't provide the business benefits that the people thought they did when they went to the cloud. Doesn't mean the cloud's not good. The cloud is wonderful. The cloud can be secure. There's so many good things about what we need in the cloud. But what do we need to be sure to make sure architectures work? We need to know what problem we're solving. That's the reason a doctor doesn't write a prescription until they actually assess the patient and understand the patient's diagnosis, understand what other medications that patient's taking and how those medications can interact with each other, as well as those patient conditions. And that's what goes into prescribing a prescription. What goes into actually prescribing an architecture? Guess what? The same thing that goes into a prescription. Learning the client's needs, learning the client's goals, learning the client's challenges, analyzing what their current technology platforms are, their business processes, what they are, and then evaluating what they need in the future unique to their needs and pick out the right tools and the right technologies. But we don't know that prior to things. So these well-architected frameworks can be a little on the be precarious, be cautious side, because they're giving you a solution to a problem that you don't even know that you even have yet. So I kind of hope that works. So tomorrow, we're going to really start a cloud platform on infrastructure and operational security. So we'll talk about securing cloud platforms and the mind shift that you need to do and considerations for securing. And we're going to start having a lot more fun. So going to try to get you guys to close on time tonight. And I'm going to open it up for opportunities for questions for the next 10 to 15 minutes or so. Because that's a pretty big shift in what we're going to talk about tomorrow.
Exactly. All right. Let's take a look. I know there was a statement. By the way, Scooby mentioned, looks like a worthy investment and you will be able to get appropriate candidates prepared correctly. You're 100% right. It is a very good investment, Scooby, there. And like with anything, right, you do your homework on it, see how it fits into what you would like to do as well, and then also around you. Because sometimes reality is not every particular position or role is available in our area. But it is truly a very, very good investment. Right. Let's pull up the comment from Anthony King so that we can address that as well. So Anthony King he's addressing what we discussed earlier in regards to how to avoid vendor lock-in. So that's going to be the context there. So we're talking about resilience while he's bringing it back and trying to touch on the security aspect. He says multi-cloud strategy can easily be negated by creating service single point of failure by introducing single sign-on as an example that forces connections to a single point. Okay, so first of all, Anthony, you're 100% correct with what you just stated there. And that is why when it comes from the cloud architecture piece, meaning the infrastructure, the applications, we generally do not try to design systems with single point of failures. Now, you're specifically calling out an authentication method from a single sign-on. So generally speaking, and this is, I kind of alluded this to a little bit earlier, even though the CCSP does not cover it in depth, the zero trust architectures, every cloud provider is going to have a variation on how they take the guidelines of what is mentioned in that framework, and they're going to apply to it. So for example, let's say that you have this issue that you described, that a single sign-on service goes down. In the principles, so in the spirit of zero trust architecture, which is something that you would take a look at in your holistic approach to security anyway. It's one of those guidelines and frameworks that is also recommended by the by NIST itself, and not just the cybersecurity framework as well. You have the open group. Those are the same people that brought you the TOGAF examination as well. They initially took over the Jericho Forum's idea of zero trust. Google has their own, with Beyond Corp was one of the big use cases of zero trust. But in either case of it, what you would have is you would have multiple SSO services that you can actually authenticate against. But even aside from that, in the spirit of zero trust, SSO is only one input that you could use in authenticating what we would generally call an agent. Now, an agent can be made up of multiple of characteristics, such as username, password, device firmware, a device serial number. You would also look at the operating system. Then you can include more context. It includes day, time, location. Depending on how you want to authenticate and authorize eventually, you can also use digital certificates. That's also going to be part. You can do that both when it comes to your actual devices, and you can also use digital certificates, of course, when authenticating the user themselves to a particular service. That's something that we discussed about a day or so ago in regards to mutual authentication, instead of just having one side actually do the authentication.
Yes.
So when you look at it from that perspective, I'm not trying to say that what you're saying is wrong, but the context of it is very important.
Yeah.
One was in resilience, and the other one has to do with actual availability and security. So I just want you to keep that in mind, that if you're going to approach security, you want to approach it from a perspective of, how do I mitigate a single point of failure? And that's generally speaking where something like a zero trust architecture will come in place, without going too far down the road in regards to what zero trust actually does.
Yeah, but
Very
when
good
we talk single, I think that's a good point. I actually like the way. So let me just show you the connectivity that you would use to connect to the cloud provider to mitigate a single point of failure, and talk about what Mark and I are actually talking about. So in this particular environment, let's say I have a data center here, and this has to be everywhere. So if this is my data center, and here's going to be my cloud provider. But let me just take this. I'm going to unfill it. Then I'm going to put 2 data centers in the cloud provider. And I want you to think about how far we have to break this down. So let's say this is an availability zone in a cloud provider, and another availability zone in a cloud provider. And let's talk about real high availability versus what they would talk about. So if you were to connect any kind of connection, whether it be a VPN or a direct connection to the cloud provider, here's what the cloud provider would tell you. They would tell you you have a high availability setup for this reason. And here's what ultimately will happen. The cloud provider has a virtual router which runs on all their servers, so you don't know where this thing is really. So it's not going to go down. And if you had a single router that's going to connect to the cloud provider, and a single ISP that connects to the cloud provider, you have a couple of things that can go wrong. This link to the cloud provider could go down. This router could go down. The router, if it loses power, will go down. If the circuit breaker to the router goes down, if a cable is cut underneath the ground, if it goes gone, if there's a problem with the service provider's network. So there's so many things that could go on. So how would we do this for a high availability perspective? And now we're still going to have the same cloud provider's virtual router, but what we're going to do here is we're going to take two virtual routers on the cloud provider side, and then I'm going to show you how we would connect to it and how we would connect to it differently. And I think this might kind of get you to start thinking about some of those high availability things. So these are now two cloud providers' virtual routers, which can't go down. Now, this router that I have has to go away. I can't deal with a $2,000 router or a $3,000 router connecting an enterprise that's got mission critical requirements to the cloud. Here's what I now need my router to look like. And I just want you to see. So now I've got a box. Here's my router. Now let's talk about the things that can go wrong on this to kind of put it into context. So my router is going to have a power supply. Where is the power supply plugged in? The power supply that is going to be plugged into a power distribution unit on a rack. If this power supply over here, just to put it into argument's sake, is plugged into this power distribution unit, which is like a power strip, and the circuit breaker goes on this power strip, I've got a problem, right? It's going to take me down. So when I'm dealing with a high availability router connecting to the cloud provider, I have two power outlets, or I've got two power supplies on them. Each one is going to plug into a different power distribution unit, and each power distribution unit is going to be on a different circuit and a different circuit breaker, so I can lose things. And in an optimal world, this one is on one generator and this one is on a different generator in case one of my generators failed if my backup power failed. Now, that's still not going to be enough to build a high availability router here that's connecting to the cloud. And we still are not going to get away with one router. Now, the routers themselves, typically speaking, have a brain. That's the part that has the CPU, runs the routing, but it's typically called a control module. So we've got a device involved in networking, and if the device goes down, we lose connectivity. So can we have one brain in there? Of course not. So in a high availability router, we're going to have two control modules in case one of the brains collapses, the system is still up. Now these devices are going to now have line cards in them where we plug in the cables. So now imagine we've got 4 10 gigs links to the cloud provider. Again, this is no big deal. What happens if we put all of these 4 10 gig links on this card and the card crashes? We lose them all. So now what we might actually do in a high availability environment is now have 4 of these cards in each router. And we might actually, we put some more cards in these router. We might actually plug a cable into each card and create a link aggregation group across 4 cards. Now, this, as you can see, this router is now plugged into 2 outlets across 2 different circuits that are going to be attached to 2 generators that have 2 control modules that have 4 line cards in it, just in case something goes bad. So that one's not going to be enough because now it's another single point of failure. So now we're going to need another one of these sets of devices. Now, when we get this device that are getting these connections, if these connections can't be on the same internet service provider, that's like backing up AWS with AWS. That'd be insanity. Nobody would do that in the networking world, not for 30 years. We use another vendor. So now we're going to have to make sure that this link is on one internet service provider, say it's AT&T, and then the bottom link that we're going to have here is also going to be in another service provider. It's going to have to be Verizon. And not only do we need to make sure that we're dealing with different companies in case AT&T crashes or Verizon crashes, we also need to make sure that the fiber under the ground is actually distributed through the building on a different pathway. So these are the kind of thinking that goes into high availability. No single points of failure, whether it be 2 power supplies, 2 brains in the router, 2 connections, 2 different companies. And this is the kind of stuff once you're taught it by someone, it's so simple and obvious to you. But when you're not there, you don't even know where to begin. So I wanted to add a little to that. This is the kind of level that Mark and I get involved when we design for high availability. We have to plan everything, which is why we do so much planning as architects. I hope that's kind of opening the eyes to you can see why it is, which is why we say this is something that we love training people for.
Yep. And we'll take one more question because I got to try to keep Mike on track. This is from Cloudy. They're wondering, don't they each have their own site-to-site connection, such as ExpressRoute and Direct Connect, with built-in redundancy?
You mean cloud provider to cloud provider? Or do you mean yourself to the cloud provider? So realistically speaking, a company will have many wide area connections. Now, what those wide area connections will be based upon their needs. Maybe it's a software-defined WAN, and Mark can tell you far more about that than I can. Maybe it's a SASE WAN, and again, Mark can tell you far more about that than I can. Maybe it's a private line. Maybe it's an IPsec tunnel. Maybe it's an IPsec tunnel over a software-defined optimized WAN. So lots of things that are going to be there, and how we want the traffic to go from point A to point B, whether we want them to transit our WAN, transit the cloud, will determine a lot in how we design our routing and setting it up.
Yeah.
But thankfully, most of that is network architecture, and that is a completely different career, albeit a much more technical career than the cloud architect career.
Yeah. Let me put it this way for everybody. Even the little security piece that you might be able to layer on top of that type of infrastructure, if you want to call it that, is going to be handled by the network architect and implemented by the network engineer.
Yeah.
Now,
Yes.
would it be beneficial that, and we'll get into it, we already got into encryption, of course, but things such as IPsec, then you also have MAC security, which is device-to-device security when it comes to the actual cross-connection between the switches, or as the cloud vendors so nicely call them, routers, because they want to confuse you more. But in either case, it is not something too much that includes the security planning aspects that you've been doing here. But to keep us on track, everybody, please give us a hashtag CCSP as we're ending today's session for us. We hope that everybody had a lot of value in what we provided to you for. There's a lot of exciting things coming tomorrow when we start talking about infrastructure security as well as operational security. We hope that we will all see you there tomorrow as well, 2 p.m., just like today. And if you haven't yet, make sure you download the free study guide that comes with this bootcamp, and as well as hit the like button and subscribe if you haven't done that before as well. Any closing remarks, Mike?
I've been having fun with you guys all week, and I love so many people have come from so many different parts of the world. I love that we've collaborated and put our heads together to help people build careers, and we're doing this all free, which is one of those fun things that I like to do. Try to do as much as I can for free to help others, and I really appreciate whether it be Mark on our team that's helping out, or Chris, who's behind the scenes doing more work than any of us can even possibly imagine to make this happen, and the rest of the team that's assisting. So thank you so much for being here. I am thrilled that you're here, and look forward to seeing you.